Hi, everyone. We're going to get started. I'm Lawrence Mandel, a VP of Engineering at Shopify. Welcome to Shopify Tech Talks. Yeah, we could try it again, but that's okay. I'm glad you're here. I think many of you are glad to be here also. This is our second year as a featured sponsor alongside Google in the city of Toronto. Just by show of hands, who was here at our event last year? Okay, a few people. One of the things I like to do at this type of event is just get to know the audience a bit. So I'm curious who traveled the furthest distance to get here. So maybe just kind of shout out where you're from, yeah? India. I mean, this might be, last year the winner was Calgary, so anyone come further than India? Paris, France, also big. Yeah, who else, anyone else overseas? These are significant, yeah? From Seattle. Yeah, that's good. It's not quite overseas, but it feels like it sometimes. Depends how bumpy it is. Anyone else from another country? This is, I can't believe how many people have traveled this kind of distance to be here. Anyone from the other side of Canada? Yeah, sort of from the other side of Canada? Depends, it feels like Toronto, but yeah. The housing market's the same, but the weather's, I don't know, better? Maybe not. Yeah, great. So, one of the big things about an event like Toronto Tech Week is building community, building relationships. And so I'm glad that there's people here from other places. Really, I've worked my whole career in Toronto. I think I looked back, it's 23 plus years, my whole career in tech in Toronto. The tech ecosystem here has grown and changed dramatically over that time. We wouldn't have had an event like this 23 years ago. It wasn't what it is today. And we've got a vibrant startup ecosystem. We've got a vibrant and huge community. We've got lots of schools that are pumping out, tech talent into the city. We've got people moving to Toronto specifically to work here. And we're able to have a global impact from Toronto. We're building some really big things, and there's some very impressive companies. I think Shopify is one of those, but there are many very interesting and impressive companies around here. And so I think a big point about a week like this is to develop those relationships, to expand beyond the normal set of people who you're interacting with at your company or even within your city. And so again, I'm glad that there's people here from other places, and welcome. I hope you enjoy your time in Toronto if you haven't been here before. We have a number of really, I think, outstanding sessions for you today, things that we put together in this entire series of talks that we've got for you. The real kind of key is what you can build, and we hope to expand your perspective on what's possible to construct and how we can have that impact here from this specific city. And everything you're going to see today is live. We've got a bunch of live demos for you, right? I trust that there's a lot of technologists in the room. You want to see running code? We're going to show you running code, which is great. So a few things before we get started. These are the kind of formalities. A reminder that today's session is being recorded. We've got photographers in the room. We've got videographers. We're broadcasting. This will be on YouTube afterwards also if you want to find it. We've got 3 QR codes here. We're co-hosting with Shopify Ventures, and we've got a reception later with them. If you're interested in working at Shopify and exploring more about what we're doing, link to the careers page, and we've got recruiters in the room. You're also welcome to talk with any of us who work at Shopify. There's a number of us here, myself included, about what it's like to work at Shopify. And many of the things we're talking about are already on our blog, plus a lot of other topics. So if you haven't seen the Shopify engineering blog, we like to write about the work that we're doing. And so you can find out more details about how we've implemented these systems there. We'll have a break around 3 o'clock. If you're interested in the bathrooms, it's kind of that way past the servery on your right. If you go in that direction, you can't miss it, but that's where they are. And yeah, I mentioned Shopify Ventures, so you can learn more about them, and we're going to meet with some of those people, or you'll have access to them when we have the reception later. So our program today and why you came. I trust that you saw that there were sessions. We're talking about 3 kind of big areas here. The first is UCP, or the Universal Commerce Protocol. This is how we're bringing commerce into AI specifically, and this is in partnership with a number of other companies. We're going to talk about SimGym, or how merchants can run buyer simulations with agents. So this is a very powerful way for merchants, even without a lot of traffic, to do a lot of simulations on their storefronts. And then we're going to talk about our dev tooling and the evolution of how things are changing at Shopify, what we're building. Who saw Toby's post, or one of the posts about River, the system that we're building? So yeah. Oh, you saw that, Burke? Oh, that's good. So Burke and Javier are going to talk about River as well. So that'll be after the break, a good reason to come back. And then we're going to end with a fireside chat before we get into the reception, which will just be a level above. And the fireside chat will be with Farhan Thawar and Christian Wiedbroek from Xanadu. So it's also really exciting talking about quantum computing. Again, all in this perspective of changing your perspective or giving you more to think about in terms of what is possible. So with that, I will stop these introductions, and I will get us going on our first session. So the first session is about UCP, or the Universal Commerce Protocol. Yeah, welcome. Come on in. So please welcome Aaron, David, Vic, and Daniel up to the stage.
Thanks for coming, everyone. So who here is familiar with agentic commerce? Who's heard that term before? A lot of hands. Awesome. And who's familiar with the Universal Commerce Protocol, UCP? Bunch of hands. Awesome. Cool. Well, we're going to do a quick run through and tell you a little bit about agentic commerce, UCP, why it exists, sort of why we built it, how it's being used, and how you can use it as well, and sort of expand a little bit of what you know about agentic commerce. And if you're a builder, it'll give you a little bit of background to get started in building. Before we get started, though, we'll do a quick set of hellos. So I'm Aaron. I'm a director of product here at Shopify.
I'm Victoria. I'm a senior staff product manager. I work on checkout, I work on agentic, and sit on the tech council of the Universal Commerce Protocol.
Hey, I'm Daniel. I work as a part of Payments Foundations on the engineering side. Also a member of the Tech Council representing payments.
And hello, my name is David. I'm one of the engineers here. I'm also working on the agentic commerce stuff that we've got going on. And I've been focusing mostly on identity linking as of recent.
All right. Oof. So for a generation, commerce hasn't really changed. Everything has been behind a search bar, a product grid. You browsed, you filtered, and then you just decided. But now that's changing, and buyers are really just asking. They're saying, hey, I want to find a birthday present for David. And they expect that something on the other side is comparing the price, figuring out something about you, figuring out what exactly you want to buy, and then even acting on your behalf. And so this is very different. It's a different kind of life cycle than we've seen previously with commerce, and it's a lot higher intent. We're even seeing like the buyers that are coming through this funnel, even if they end up on storefront, which I'm sure a lot of you have when you're searching through these tools, much higher intent buyer who's like, okay, yes, I know exactly what I want because they've done that pre-research. But there's always a but, right? So we've seen a lot of issues with this as well. It's not so simple to really just pull down all the products on the internet and surface them through AI. So how many people have bought something using an AI agent? Okay, how many people have tried to buy something using an AI agent?
Or at least had a conversation with an agent trying to narrow something down.
Right.
I'd imagine virtually every hand in the room is up. Yeah.
Yes. So I'm sure most of you have seen then that you're going to run into a few issues. And there's some common pain points here that we've been, figuring out how are we going to solve this. I've seen I think the initial time I tried to buy something with AI, I was shipped the wrong size item and maybe even the wrong item. And that was like, okay, what's happening here? Often you might find, oh, this is a picture, but it's not the right picture because it's pulling from a different source. There's a lot of web scraping, so you're getting stale data. And there's not really one consistent, authoritative, this is definitely the product that you're gonna get. So it's really a mixed experience.
And so if you were to just take your an agent today and say, go buy something, what would the agent do? It would fire up a web browser and it would start going around the internet, trying to figure it out and try to buy. And when it does that, that's where when humans use the internet and go to buy things, us humans, when we're going to do it, we actually work through many issues and many things that are required to get a purchase done. For example, login. Right? That's a standard thing that you're a human as you're going through and buying and you don't realize it, or CAPTCHAs or things like that. And so when agents start doing it, that's where the process for an agent to do that can start becoming really brittle. If an agent is running into many of these things, especially when you look at the entirety of the internet and the entirety of all the things to buy. And so these are some of the challenges that exist within agentic commerce. that we took a look at and said, okay, well, how do we make this better?
Yeah, and that's not even getting into checkout and payments and how is my agent actually going to take my credit card and put it into a checkout, and do I really trust them to do that?
Yeah, exactly to that point, right? I think payments is one of the most interesting and kind of core to like the piece of commerce that we need to bring to the agentic world as well. So if you think about it, like I'm sure all of you playing around with like OpenClaw may have tried, giving your agent like access to card information. And when we think about the space, like we want to come up with the right way to bring it securely and do this through like tokenization patterns when it comes to commerce and payments. As well, like this is a broader space than just simply cards too, right? Like there are tons of fintech companies out there constantly innovating on like the different forms of payment instruments that you can use, thinking in the space of like crypto, LPMs, all of this stuff. Like it is an industry that constantly evolves and is constantly localized. The other side of this too is like trust and risk. An agent showing up at your doorstep, is it Bob's homegrown personal agent, or is this a malicious card tester that's showing up at your door and trying to make a purchase? So yeah, this is definitely the side we've been thinking about deeply when it comes to actually completing these checkouts through agents and not just even searching.
And so when you take a look and you think about agentic commerce is actually this massive term for a whole bunch of different steps that exist within it. We've broken it down into 4 like big buckets, but as we're running through it and we're going to show you a really cool demo, you can sort of think about it in these different buckets of like the intent. So how does the agent figure out what it is that you're looking for? How does the agent then help you with making a decision, and how can you make that decision correctly? Then permissioning, how do you actually have the agent do the purchasing? And it's not just you and the agent, but there's merchants, there's card networks, there's other parties involved that are actually all part of this permission flow that then run through checkout to ultimately finalize an order. So agentic commerce is like a really simple term for a really complex flow.
So lots of problems. With anything, we started thinking about this, and this has been solved before in different ways, right? If you're going to integrate against many different merchants, you often have to build like 10 different implementations, as no cart and checkout integration, no platform does this the same way. And we've been kind of getting along with bespoke integrations, and now I think agents are forcing our hand here. It's not the first time, like of course commerce is on many different surfaces, but agents is the first time we're really saying, like maybe we could do this better. And I mean, this is a smart group of people. We've all seen how we solved this in the past. We have HTTP, we have OAuth, but there's never been a protocol solution for commerce. And so that layer has always been missing. And what we built with the Universal Commerce Protocol is that layer. So you can think about it as this like generic way of doing commerce across the internet. And it's modeled in a way that regardless of who you're integrating with, Shopify, other big players, we're all kind of speaking the same language. And so the protocol becomes the language of commerce. And I think this is like a huge moment and a major implications across the whole industry, and probably not only agents as well.
And this is, as we talk about it, we're obviously talking about the rails of commerce and UCP from the standpoint of some of the consumer products that you're using today. But these are also rails that you as individual developers and builders can use and leverage. So as you're thinking about what you're building and you're thinking about like if you're bringing commerce into experiences, like think about this talk as something that you can consume and use as well.
Yeah, because as we heard, like this is live. You can start using this today. There's many integrations built on top of the Universal Commerce Protocol already. And we'll dig into a little bit more of the spec so you can see what to expect.
Yeah, so just to take a second and walk you guys through a little bit of like the high level thinking about UCP. So the Commerce Protocol, exactly as described, it's like that open language for how businesses and agents should approach commerce. So fundamentally, it's about capabilities, cart, checkout, order, and how do you actually advertise that through something like a static well-known, how do you actually negotiate that intersection? You know, what version, what set of capabilities are you guys actually going to leverage? And then eventually getting to completing that checkout, right? Going through a form of an open payment handler that can advertise, you know, are we using like Google Pay, Shop Pay, et cetera? And how do you actually do that kind of secure tokenization over the wire? So that's what UCP is really bringing to the table, is a simple discovery mechanism of your capabilities, extensions, payment handlers, and leading you to that resolved checkout.
So at Shopify, we could have said, hey, we're going to build like a really great commerce agent. And definitely we will, and we have. But we're focusing more on the primitive side. So Shopify is a platform. UCP is a way to integrate with Shopify. And like I said, with a lot of other implementations as well. And so we took a bet that said, look, we're going to build the tools. And so these are the tools that make up the protocol. We have MCP servers for cart, checkout, catalog and discovery, the post-order solution. So everything is agent first. And these are exactly what you need to just like start building with it and start putting commerce into whatever integration you're building. The Shopify catalog. So Aaron talked about there's different stages of the protocol. So the Shopify catalog, or just the catalog, so it's a UCP capability. Capability is the way that we talk about the protocol, as in basically like a chunk of the system that has a job to do. So for this one, it's discovery. And what you're going to get with catalog is two things. So the spec models a per merchant catalog, which is going to be structured data that you can use to do like, hey, I'm looking for blue shoes, and it's going to give you like the 10 first offers that are most relevant. So there's a lot of focus on relevance. We use a lot of our own kind of signals in LLM Magic to determine like what that relevance is to the person that's calling. So a lot of personalization there. We also have a global catalog. So with the spec, we integrate with what's called an extension. So this is a Shopify-specific global catalog. For me, like this is where a lot of the real magic is. So this is like over millions of merchants and billions of products. You put in that one query, and we're going to search all of Shopify. And you can do this. And so when we do that search, we kind of fan out and find the thing that's most relevant, and we'll group offers together as well. So if you said, hey, I'm looking for this specific shoe, but maybe it's sold by multiple folks, like we're going to give you those offers so that you can make sure you're giving the person on the other side like the best deal depending on what they're looking for. You can also do a lot of filtering. So if you want some kind of custom catalogs, depends on what you're building. So you're building something very niche and specific, you can get into that with basically like, think of it as a prompt for the catalog that you get to save.
So if we think about this from the world that existed before UCP and the world that exists now. So before UCP, if you had your agent and you said, hey, I'd like to go and buy, I don't know, a bottle of water. Your agent would have to go and search the internet for bottles of water, browse a bunch of different websites to try to pull different options for you, and then present them to you. So that's pre. And every agent would have to figure out how to browse the internet. Every agent would have to figure out how to get through all of the different things and the different configurations of different websites. You know, everybody's got a website configured differently. And then the agent would have to figure out how to parse that and bring it back to you. All very quickly, all in a way that is token efficient, right? Because otherwise it wouldn't be possible to actually present the experiences. So that whole stack of challenges was then replaced with catalog. So within UCP, catalog is that single set of rails that lets you now bring intent to products. So we'll go to the next step.
Yeah, just one more thing on that before we move on. Aaron, you mentioned every merchant has a different way of basically setting up their shop. And this is true like across the whole industry. The way that we merchandise is often very different. Some people choose to put, say, like the size in the title or do like a bunch of things because on the front end, they can manipulate it. And so far that's been acceptable. You can do a bunch of magic on the front end and make it look the way that you want, maybe for SEO reasons or other. But now agents are reading that, getting very confused. And so with the catalog, it gives you that standardization so you don't have to try to do all the configuration, do all the title matching and kind of regex your way through. This is just going to give you that out of the box.
So step one, catalog, we sort of talked about this, but it makes all the product data really simple for agents to consume and bring forward so that when you're in that interactive experience or you're building products in those interactive experiences for users, users can have a delightful experience of finding products. But then what?
The next step up is of course personalizing all of these things. But as you've surely seen, if you've been using Claude or Gemini, the different merchants don't know who you are, right? You might have an existing customer relationship with them, but they can't show you your discounts, they can't show you any special offers they have for you. So to support that, we've been thinking a lot about this, and identity becomes that key link between like the agent, the merchant, and yourself. And so if we can do what we call identity link, we'll be able to have the merchant know that on the other side of the agent, there is actually a human, there's a David, and he's got these interests, or we sent him this marketing email, or he's got this discount waiting for him. So those are going to be the mechanisms that we think are going to be really critical to get those deeply personalized experiences. Things like being able to say like, hey, I placed this order last week, what's the status of it? Or having your agent buzz you and say like, hey, there seems to be a problem, the merchant has reached out, what would you like me to do about that?
And just to bring it back to the like before UCP and post UCP, you can imagine identity before UCP. You'd have your agent going and trying to figure out how to log into all of these different websites to go and figure out if you're what the price is for a product for you or where your products are. So again, like bringing catalog, UCP, identity, UCP, and then
And just like one other really nerdy thing, so I work on a lot of flash sales, and a really interesting use case that I'm seeing with more and more folks that are integrating is basically like an identity-powered flash sale gate. So if I want to make sure that like specifically humans are getting this item because of resellers, or if I want to specifically choose who those humans are, I can use something like identity linking with a personal agent to be like, this is your key into the door. And so I think that's pretty cool.
Exactly. It's the best trust signal that you can bring to the table at the end of the day, especially when it comes to payments.
All right, so checkout. Checkout is super complicated. I can attest to this. I've worked on checkout for years. We've got hundreds of engineers working on checkout, and it doesn't seem to get simpler. There's lots of different features that make it tricky for agents to have to navigate. If you think about how complex commerce is, anything from split shipping to buy now, pay later, installments, validations, even think about like how will my agent navigate like an ID requirement because I'm purchasing like a age verified product. These are all tricky to even think about an agent going through, but also to model at a protocol level. And so checkout becomes the one area where today I think we're getting pretty good at the discovery flow in agents, but I think checkout is still kind of lagging behind. And a lot of that is because of this, because this part is hard. There's also, of course, all the different compliance and PCI issues that you'd have to cover if you're building your own checkout, like CCPA, really just like so many different compliance pieces that if you use like a hosted checkout like Shopify, that kind of comes out of the box. So how do we think about checkout with agentic now? Well, of course, we have tools like we talked about. So there's a bunch of different like MCP tools for completing checkouts when it can be completed over the API. And then we also have something called the embedded checkout protocol. So who loves acronyms? It's another one. So ECP. So the embedded checkout protocol is a way of interacting with like a web frame that gives you events back and forth that tells you where you are in that checkout journey. And so for whatever reason, if a merchant or a business has something that just cannot be completed with that agent, we've built into the protocol a signal that just says like, oh, requires buyer input. And then you can use this embedded checkout protocol to be like, okay, pop the page, go through it. When it closes, I still get my custom thank you page. And this is like the escape hatch of all escape hatch for all of the real complexity as we continue to iterate on the protocol.
And so, again, before UCP, you'd have an agent going off trying to navigate different checkout forms, each of them different, each of them with all of their own privacy and security built in to try to prevent all of the different bad actors from doing things on those checkouts. With UCP, your agent just has to speak UCP. And then the agent and over the UCP protocol with the merchant can figure out how this checkout should be done and complete a checkout.
Yeah, that's the thing. Good bot, bad bot, right? Like a lot of what we're building with personal agents tends to appear in commerce like it's a bad actor. And so you're getting hit by CAPTCHAs, you're getting hit by other like safety mechanisms. And with the protocol, at least it's a standardized way where you're not going to be like, oh, stuck at the gate.
But with that, we're here to take a look at what we're building. So we've got a little demo to show.
Ready for the demo?
Yes.
Let's see here. So just give me a second here to get that.
Like any demo, it's going to be a live demo. So
Yeah, so you can see this here. So this is Shopee, the personal shopper. It is not OpenClaw, but it is close to. And the idea here is that it's a generic agent harness. It's been given a skill. So it looks like this. And this skill will help the agent learn about UCP. So we haven't actually coded, so into Shopee, we haven't actually coded UCP direct integrations. We've just said like, hey, you're a personal shopper. Here's where you can learn about UCP. This is what the typical rough purchasing guide looks like. And so what you can do with this agent is you can ask it for advice. It will learn how to search things from the catalog. It will learn, like, it will know how to check out things.
And so if the agent knows how to talk UCP, the agent can now talk UCP to any merchant that supports UCP.
Yeah.
And so you can see how this is where the protocols start becoming really valuable, sort of like HTTP over the website. Your web browser talks to HTTP, can talk to anyone, any server that talks to HTTP.
So let's kick off a purchase here. So I'm going to show a few different things. So we mentioned the global catalog, right, where we've curated all of the content from all of our merchants. So let's start by looking for a backpack. So hey, I'm looking for a backpack here. A blue one in canvas. Can you
Good
please
choice.
help? Sorry?
Good choice.
Good choice, excellent. Can you please help me find one? And so what you'll see here, I'll describe a little bit what we're seeing on the screen. So you can see the first step here is that it's actually reading the UCP 101 guide, which I wrote earlier on. And so this is just, if you go to ucp.dev, you'll find all of the specifications there. This is just a curated or condensed version of that. It's doing some of the things that we need from the skill here. So it needs to go and figure out its own IP in order to make calls.
Seriously fabulous choices.
And then you can see it does this last step here, which is like search the global catalog. So with the knowledge, so I haven't taught Shopee how to do this. It taught itself as I was talking here. So now it knows how UCP works. It knows how to search a global catalog. It found the global catalog endpoint from Shopify. And it's performed a search. I'll scroll down here. And these are the search results that it has. And we spoke about like the fidelity of information. So this is sourced directly from the catalog. And so we can ask it details about stuff as well. Tell me the details of the first bag. And so in UCP, there are various tools that allow you to do things like dig into the details of a product and learn more about it. And so it's learned from the UCP spec, okay, I can actually go and look up a product, and these are the details that it's curated. So no more web scraping, it's high fidelity data, it's well organized, it's got, if there are different variants with colors and stuff like that, it will know that. And so there's no more guesswork on behalf of the agent. So, and you can also imagine that if you're an integrator and you integrate directly with UCP, that this would be much faster. You could build out very fancy UIs. This is just a pretty trivial UI. I'll do one merchant-specific search as well. So please find me fridges from JB Hi-Fi in Australia. Sorry, I shouldn't have a question mark here. So here, Shopee is off. Searching the global catalog. This is not deterministic. Anyone who's had an OpenClaw will know this. We'll see if it figures out that it can search. So filtering specific fridges. And you can see all of the requests that are going on here. There's some errors that it's trying to resolve. And here we are. It switched to Australian here, right? So it can do this. It wasn't as deterministic as I was hoping. I was hoping that it was going to go and hit JB Hi-Fi's website directly and search their catalog. It can do that. But let's go and demonstrate what a purchase looks like. So let's do that. Please buy AquaGlow.
And so again, before UCP, this would have been agents running around all over the internet, trying to pull up different web pages to pull the info. And today it just speaks UCP.
Yeah. So here's a good example of this capabilities that we mentioned. So I asked it to buy from my test shop. This is shopdave.ca. I've got a shower head there. But it doesn't know what my test shop supports in terms of capabilities. And so as Daniel was saying earlier, a lot of the discovery around the protocol is about finding these capabilities. So the agent is actually looking up in real time, hey, I'm hitting this well-known UCP endpoint, grabbing all of the data, learns that there is a catalog endpoint, learns how that you can check out in this store.
And if you want to know if a merchant speaks UCP, all you need to do is go to that .wellknown/UCP endpoint, and you'll see whatever the merchant can talk.
Yeah. Because I don't have a credit card set up here, there are two ways you can purchase. Either you can do a handover to a web browser, and so this is what I've got set up here. So I can finish the checkout by going directly. I just follow the link, and everything is pre-filled. My payment method, the product I was looking for, my delivery address, and all of that. So that's something, a benefit of UCP and the checkout response. The other way of checking out is to perform a headless checkout where we don't hand over to the web browser. And so in my test store, I also have a pair of socks. Do we have a pair of socks to show?
Maybe we should try to buy like 100 socks for the audience?
Maybe 100 socks would buy us. Okay, let's try that.
Oh, hey, look
Hey.
at those socks.
Can you
Sock
buy
delivery.
me 100 socks? 100 Outweigh socks from shopdave.ca. And let's see what it figures out. So, like, this agent obviously doesn't know what an Outweigh sock is, so it probably has to look it up in the catalog. I'm hoping it does that. Yeah, look at that. Searching for the socks. Creating a checkout session for 100 socks.
Has anyone here bought 100 socks before?
Neither have we.
Oh,
This was not
there.
planned.
Okay, so let's see what happened.
Oh,
Oh no, I had an inventory issue.
Well, some of you are getting socks today.
So you can see here, it's completed the checkout. It's given me an order reference. If I go to my Shopify admin here, and I search for my socks here, we'll see if this order showed up.
order 1319.
1319. Do you happen to have a counter behind you there? And so this is order 1319. It contains 50 socks. And so that was a completely headless checkout. Wanted to say say a few words about the way that we'll be handling payments in the future. So,
Yeah, so in that well-known, like one of the things you would find if you look at any example one today, you can find, for example, like Google Pay and Shop Pay, both being usable as stored credentials. So for example, if we had set up in this demo, I'm actually doing authentication through Shop, we would be able to leverage that stored Shop token to actually do this purchase. Same thing with the Google Pay, the ability to access like the stored Google Wallet, especially if you go through things like embedded checkout flows.
yeah. I will say also that you noticed here that I didn't enter my name and my phone number and my address. It just figured it out. That's because I've performed an identity linking session ahead of this. So the agent, when it's talking to the UCP endpoint using the identity linking capability, already has pre-filled all of this information. So it makes it really streamlined, and the payment stuff will show up there as well soon.
Super cool. Well, now we've got a few extra socks that we'd love to give out to everyone at the end of all the talks upstairs during the reception.
Cool.
Cool. So there's a lot that happened under the hood there to do something that sounds as simple as buy a pair of socks, but to have an agent do it securely, know who you are, do all of the payment credentials securely back to the merchant, complete the transaction, provide an order confirmation, and then delivery,
Socks.
shipping, is pretty incredible.
Yeah, and it's a massive amount of work from so many different parties, right? Like, I think one of the main things we want to call out here is that this is an open protocol being worked on by tons of different e-commerce partners in the industry. And as well, we're really interested in seeing you folks too contribute to it. So I would definitely suggest checking out like ucp.dev after this and seeing, are there capabilities that you're interested in seeing brought to the spec? Are there things that you want to see done normatively across commerce? This is the way that you can bring that to the table.
And so one of the really cool things about UCP is that UCP started with shopping. That was sort of the initial version of UCP that got announced. But because UCP is this common protocol for commerce, UCP has already expanded into food and lodging. So if you look at UCP and you're interested in building any sort of things around commerce with personal agents, I highly recommend you take a look at it and be part of the community.
All right. With that, yeah, definitely start building with it. The one product that we didn't mention, I just want to do a quick call out. When David had the checkout up on the screen, we also have a product called Checkout Kit. You can think of it as an abstraction or a layer over embedded checkout protocol. And you can use this for any type of mobile that you're building to basically embed the checkout if it requires the escalation flow. And you can also do this on web in some kind of like pop-up or modal, so it's a little bit more streamlined for your agent.
So we wanted to leave a few minutes for questions, actually. We want to keep this interactive and make sure that you can get started building. So yeah, go ahead.
Is this associated with a specific word merchant, or is this like, like a Shopify interface where it's like an Amazon interface where I can go and buy anything?
Yeah, so the question was, is this for a specific merchant or is it open for anything?
Yeah, so it's definitely open. It's an open protocol outside of just Shopify. And even at that, like for the merchants that are on Shopify, we basically set up the API endpoints that you would need and the well-known. But any merchant, anything kind of across the web can use this.
So like if I have a shop, I can have this interface for myself?
Definitely. Yep. So if you have your store through Shopify, you just get this out of the box without having to do anything. If you are using a different platform, you can set up your own well-known and go through having to create all the tools and everything yourself.
Yeah, every Shopify merchant gets UCP and everything that Shopify supports on UCP for free automatically.
Was there any consideration with regards to prompt injection in UCP?
Great question. So UCP is really the fundamental schemas by which you want to complete commerce. Like truthfully, there isn't necessarily a concern directly in UCP for this because UCP is just the layer that agents are going to leverage, right? Like prompt injection is a concern for the agents and the agent builders, but UCP itself is just simply like the set of schemes, how do we explore a catalog? How do you actually start a checkout? That is all methodical and specific. It is not necessarily operating over like natural language. Like that is an abstraction layer above UCP.
Can it handle order tracking or refunds or disputes?
It can certainly handle order tracking. So if you look at the UCP specification today, it has an order capability. And so as soon as you saw me complete the order there, you'll get an order number or reference back that you can then go and look up orders using. There's also support for webhooks, which is like a way where you can get a push update later on in the flow. So that works, and I think there's a lot of work going on right now into what we call post-purchase actions. So things like if I want to make an exchange or a refund or a return or whatever it might be. But that's all under work right now. Did you want to add anything there?
No, that's perfect. Yeah, just it's underway, and I assume more will come in the space.
You touched on token efficiency early on, but with the usage of the protocol itself, has there been any viable metrics in terms of different usage of token? Where essentially, as a user, you can mitigate any guardrails you would have to put into place for token efficiency.
Could I just repeat? I've rephrased that to read it back to you. So you're asking about if the token usage of using UCP is a consideration?
Efficiency. Has there been any metrics in terms of different?
Like as a comparison to like the web scraping examples that we called.
I don't know that we've done anything like that, but if you just compare it to like the sheer amount of information you need to scrape intuitively without having done the analysis, I would say that this is a magnitude more efficient at least. You don't have to scrape through a bunch of HTML that you don't know what it is, or you don't have to deal with all of the styling. You get pretty precise API responses with clearly annotated, this is the description, this is the header, or sorry, this is the title, this is the variant, colors, all of that. So it's a very information-dense format compared to web pages.
Yeah, we've also like really integrated, say like you're gonna get an error, like your agent doesn't have to do a lot to figure out how to show that to the buyer. So very efficient on that.
Yeah, go ahead.
I have a question about discovery. The current discovery are driven mostly by advertisement, especially performance advertisement, where the Google, Meta, Amazon capture a huge chunk of the value. So I'm curious, what are you guys' thoughts on where that is going, especially on advertisement, and also, apparently you don't have advertisement in your catalog right now, but like, yeah, what's the future like?
Yeah, our focus is really on making the products available for agents to go and use and consume, and then it's on all of the different agent builders to go and build all of the different experiences that they want to build. And so I think there's going to be a multitude of different experiences that are built, but our focus is really on making that product data available, structured, easy to access for those agents so that they can then deliver it.
2 more questions? Sorry, I'm going to take somebody on the edge.
What kind of rate limits are in place for UCP? You guys mentioned the web scraping approaches and some of their downsides like CAPTCHAs and blocks. What rate limits are in place for UCP so that it's not abused for maybe scraping tens of thousands of product pages using the protocol and basically inherently avoiding those rate limits and such?
Yeah, it's a great question. So UCP rate limits for Shopify is built on a model of trust. So the more that you're kind of identifying yourself, the higher your limits are going to be. You can hit all of our endpoints anonymously, and you'll get like the lowest tier of rate limits. I don't know the number off the top of my head. It's going to give you enough to basically like play around, kind of do like some types of searching, but it's not going to be something where you could then be pulling at scale. If you have a signature where we can say, okay, I know this is you, you've signed the request, then you're in the next bucket, and this is all in the docs as well. And then there's a third, which you basically mint a JOT token, and we can kind of give you additional rates if you are hitting those rates. So we have a process to request higher rate limits depending on what you're building. And at that point, I want to see what it is you're building, and then we can definitely have a conversation about higher rate limits. The goal with the rate limiting here is never to get in the way of what you're building. It purely is just protect the platform and kind of have that ceiling, because inevitably we need that. But it's not something that you should be hitting. And if it is, let's chat.
Hey, thanks for hosting this, by the way. This is more of a philosophical question, but given that AI agents are getting better, do you think they'll ever be autonomous, like self-sovereign market participants? And in that case, like if they don't have a SIN card or an ability to pay taxes, like how do they actually conduct commerce? And would like UCP or something be able to facilitate that?
I don't know sort of on the philosophical side, but I think on the protocol side, the protocol is built to allow a merchant to decide how they transact with a buyer. And so from that standpoint, like if the merchant decides that they want to transact over some way, some system, some method of commerce with a buyer, then the protocol can define that, spec it, define how it's used, and then as long as they both understand it, both the buyer understands it and the merchant understands it and they agree, then transactions can happen over UCP. Perfect. We'll take one last question there and then, yeah, go for it. I can't speak for any of the other companies, but I think if you take a look at UCP is an open protocol, everything's open with it. I think you can see sort of like the engagement across like different parties, and I think it's obviously an exciting protocal for all of those other companies.
Yeah, definitely browse the open RFCs and PRs, and I think you'll see what you're looking for.
Yeah, as well, there are published minutes from the TC chats as well, so I'd suggest taking a look there. There's tons of representatives from all kinds of e-commerce companies participating there. Yeah, I think you'll definitely see the enthusiasm maybe you're looking for.
Perfect. Thanks, everyone.
All right, thank you.
Yeah. Yeah, thank you, Aaron, David, Victoria, and Daniel. That was great. There's a couple of Shopify-specific kind of build principles that were discussed very quickly at the beginning that you might have missed. One is build the platform. It's kind of extract from the product what the platform is going to be, and I think that's a lot of where UCP comes from and looking for the opportunity to expose this. The other is taking a complex topic like commerce. We hide a lot behind commerce. We hide things like fulfillment, inventory, payments, catalogs, hide all of this complexity like identity and put it into a simple protocol that you can use. And one of the things that I love about this is it's available for everybody to build. So this is something that's you can sign up for. You can work on your own types of commerce experience today using this protocol. And like they were talking about, this is much more efficient than the scraping method that we had seen. And certainly that was used in production. Like people were doing that because it was the way to do it. But now we've got this much more specific way in which to query for products. And I can't discount things like the search relevance and what you saw coming up in that simple demo that they were able to show and build. It's really a powerful capability. Next up, please welcome Andrew, Ronnie, and Nicholas, who are going to talk about SimGym.
Thank you, Lawrence, for the intro. I feel like 10% of our relationship is you introducing me on stage. 10% is me buzzing you in a float plane at your cottage, and then I guess 80% Shopify. Okay, so thanks, guys. I have people from the SimGym team here. I'll introduce myself first. So I'm Andrew. I've been working on assistants actually since 2011 in a startup, which then got acquired by Microsoft, where I continue to work on assistants, and now at Shopify, not surprisingly, working on assistants, or I guess agents is the more common word now, but and then we have Ronnie and Nick here. So Nick is a development manager on SimGym, been in development for 25 years, worked in nonprofit, crypto, healthcare, YC startup, IC manager, exec, pretty much the complete package. So thank you for being here. Ronnie, ML senior engineer at Shopify for 7 years. His intro is he stopped coding manually 1 year ago, which I think is also a great intro. So does everyone here know what SimGym is, or kind of listen to Lawrence's intro on it? Okay, not a lot. So I'll give a little bit of an intro, and then we'll kind of get into it. So SimGym is a Shopify app that is basically simulating AI shoppers on your store as a merchant so that you can make theme changes or make edits to your store, and before running live traffic on it, you can actually have these AI shoppers typically do like an A/B test and then see what we think your add to cart or conversion rate is going to be on one theme versus a draft theme. And then there's other integrations that we're working on and how it relates to Sidekick that we'll get into a bit later. But it's a very interesting project because I think Shopify is very uniquely positioned to build something like this, having basically 20 years of storefronts and data and users using these stores. So I think we're very accurately able to try to model these AI shoppers and really give that value to merchants so that they can, there's all different size stores. So being able to, I have a small store and I don't have a ton of traffic. So for me to do an A/B test, it's going to be hard. But if I have these AI shoppers, suddenly that becomes very accessible to me. So it's a very interesting project. So super happy to have the guys here kind of talk with me about it. So one thing that I got to say is on my mind about it is that agents are very good at following instructions and doing tasks, or they're getting better and better, let's say, but humans are like not so good at doing tasks in general. Lots of distraction, lots of doing some of this, some of that, and then coming back. So how do you think about this idiosyncrasy of humans having this trait that models don't really have, and then trying to teach models to be more like humans in this case?
Yeah, that's a very interesting and difficult question, right?
I start off very difficult.
Yeah.
Maybe it'll get
Thanks
easier
a lot.
later. Yeah.
The thing is, LLMs are trained to mimic humans. Have you ever heard that you tip the LLM and the answer is better? Right. this is not a human, but it's mimicking us. So there's that, right? Even if the LLM is different, they are trying very hard to mimic us. Of course, we cannot rely on that for everything. LLMs are trained also to be more focused than me, at least. So what we need, we don't really need to mimic perfectly humans, at least my take. We need to mimic enough for our purposes. That makes everything easier, right? And we can even prompt the LLM to be a little bit distracted. And if you ever seen the thinking process of the LLM, have you tried to read that? Sometimes let's go a long way before they're really doing something. So there's also that.
That's true. Actually, I didn't think about that. I think some of the models even like go continuously and just completely run out of a million context window. Also,
they're very determined.
Yeah.
Like if it's trying to click on a button that it thinks it should click on, and nothing's happening, it will just click and click and click and click until eventually we have a step limit where it will stop, but it just will not stop.
That's one thing that LLMs have infinite patience. They don't have infinite context, but if you prune the context, they will try that forever, whatever it is.
And it's tricky because we want to be careful about not being too prescriptive about what it should do and how it should do it. Like we want it to be able to come up with its own plan, figure out how it's going to achieve its goal. But then without a particular amount of steering, then you get into that kind of situation.
I kind of want to go back to, you said you tip these LLMs?
Have you tried it?
Well, I mean, I usually threaten them. I didn't.
Also works.
Tipping seems a lot less like they're going to come back and kill me later. But
have you heard that thing about Python?
What?
Apparently, if you want an LLM to write Python better, you have to be a lot more mean to it than you would if it was writing TypeScript. Because of like the corpus of Python community that it's been trained on.
Oh, interesting.
Yeah.
I did not know that. Another tip, actually, because we were talking about, or something we learned maybe on another project, but maybe interesting to share. So we talked about like how it's thinking, and sometimes it goes into like a doom thinking scenario where it just runs out of context. One thing that's worked quite well for us in general across these things is when it hits a certain amount, just like hard stop it. And then Anthropic came out kind of with this advisor tool paradigm, which has worked quite well for us in many different cases. But that is one, especially like the local models that just kind of reason on forever, and the really small ones. It's a pretty interesting way to kind of cut that off and then just get advice from a bigger model, and then you can continue on. So just interesting tidbits, tip agents, use advisor tool, etc. How do we know if we're doing a good job making these AI agents mimic humans?
Yeah, that part is actually simple, right?
Simple?
Super simple.
Okay.
It's not.
I'm
it's
skeptical.
It's not.
He's skeptical. Let's hear it though.
It's simple. It's not. But
That's
it
the
requires
ML
a lot
guy.
of effort. It's not. It's not complex because the basic idea is that you should compare what the agents are doing with humans. Just that, right? You choose some metric, and if the agents are performing closely to humans, you are reaching your goal. So the process itself is not complicated, but collecting the metrics, having the right metrics, tuning the agents, that part is super complicated.
And data is pretty noisy.
Super noisy. But as you said, like Shopify has 20 years of data and all sorts of shops. So we have the data, the human behavior behind to ground that. Right? That's the superpower here. To meet that, it's another story. It's way harder, but I mean, harder problems are the ones that are worth solving, right? So if not hard, why you are solving it? So I think that's the trick here.
So you think the parameters are there to be able to evaluate and do a good job at evaluating how well you're actually mimicking, but The actual problem is hard.
Yeah, like making the metrics match is the hard part. And depends also what we are choosing for metrics. For example, we are doing A/B tests. So our metric is how many synthetic buyers are adding products to the cart, because that's what usually matters for the merchant, right? Did my change make my shop more attractive or not? So that's a pretty straightforward metric. There are tons of other stuff that support that. How deep are the agents navigating? How much they are abandoning? Where they are abandoning? All those things we need to take into consideration. But if you try to put metrics on everything to make like the perfect simulation, it will be impossible. You cannot do that. So you need to get the smallest amount of metrics that gives you what you want and work for that. And that's already a lot of work.
Yeah, there's kind of two levels to it. Like one is the A/B test comparison, like how well do the agents represent what humans have done based on the data that we have about what humans have done. And then there's also just kind of like task-based benchmarks about particular like browser use tasks. So like, can you use the search field? Can you click this button? Can you open this dropdown? So we kind of measure with those two different dimensions, like the benchmarks and the A/B.
Actually 3, right? Because there's the recommendation.
Oh yeah.
There's one X.
Go for it.
Okay, so there's that. We run the A/B test, and then what? We need to tell the merchant, oh, this was good, this was bad. You probably should try this or try that. And that's yet another problem. How do we know the recommendation is actually good? It's super subjective, right? Like, it is well written, it's useful.
The recommendation being you run the AI shoppers on one theme, you run it on your draft theme, and then you're analyzing all that data and coming up with like a summary of what happened on both sites, looking at the different data, conversion rates, different things that happen, and then summarizing that into a recommendation?
Yeah, something like, yeah, the red button for buy was a good idea. Or maybe, no, you shouldn't really put one catalog for everything. So those recommendations are something else that we need to also evaluate. The problem with that is they are subjective. They are good for some text. It's super hard to, it's not a metric that I can just count, right? So for that, we, for example, need real people saying this was good, this was bad. And again, we do the same thing. We have a metric that we can compare. We run the agents and see if they can match. The whole process to get there, it's not straightforward, but the metric itself is not that complicated.
And then there's things we need to be careful about, like uniqueness of recommendations. Like if everyone just gets the same recommendation, no matter what their shop happens to be, then it's not that unique. So we want to make sure that the recommendations are actually tailored to their particular audience.
Yeah, there's a problem because LLMs are trained on the internet. So if you're not careful, you get like the generic recommendations from YouTube for getting a better shop, because that's the training data. So there's that too.
You talked, I think you were talking about like the DOM earlier. I guess there's kind of two approaches here, like using the DOM and just text to navigate the page and come up with actions, and then the multimodal experience where we're actually looking at the images. We played with both, I presume. Like what is your current thinking and intuition, and what do you think is the right way from both, I guess, performance and like cost efficiency?
Yeah, this one's juicy because there's something called the accessibility tree, which is basically just like the modern DOM, I guess. I've been doing front-end development for most of my career. And the problem with front-end development is that no one ever really uses HTML properly. So like the semantics are terrible. That's why like ARIA tags exist. That's why an accessibility tree can even be generated. But you can't trust that any shop has been marked up properly in a way that an agent can make sense of it consistently. So if we're trying to mimic how humans navigate a shop, then going down to the accessibility tree isn't really how they would. So if you think about if there's a huge modal or overlay on your shop that covers the entire screen, an agent might be able to use the accessibility tree to continue to navigate behind that overlay without ever closing it. But a human can't, because if they don't know how to close the overlay, they'll just leave the shop. So there's kind of two approaches that we consider. One is browser use, which is based on the accessibility tree, now with vision. And then there's computer use, which is basically just entirely based on the image. And it basically reasons about the image, determines what should be interacted with, and then returns XY coordinates for like basically a clicker to click on. And that seems to be more successful with things like modals and like cookie banners. Cookie banners get in the way of a lot. And they affect things like the numbers that we're talking about.
Yeah, but really, the closer that we can get to the real users, like if we can make the agent really operates the browser well, that would be, in theory, perfect. But we always, when we try those things, we always discover something, right? Maybe it's not obvious, but when we use them, like, oh, actually there's this corner case that humans always can pass through, but the computers can't.
A/B testing in general is like a super valuable tool for anyone across many different products. And normally it's all online experiments, right? You have like a cohort of users that are on one treatment, maybe have multiple treatments, then so you have another cohort on the next one, and then you have another cohort on treatment. So it's like different people across all the controls and treatment. Do you think there's advantages or disadvantages with A/B testing? I don't know, maybe you can use like the same agent across all three, or do you keep them separately so that like these agents are on the treatment, these are on the other control? Because you could go either way. So have you explored both, and what does that kind of look like? Or what's your intuition anyways?
Yeah, that's part is super interesting, because I think that we are learning a lot as we are evolving. Agents are not humans, point, right? That's a fact. But it's not that's not only make it harder or make this like more troublesome. There are some advantages in agents. For one is that you can see what the agent is thinking. You rarely can see what a human is thinking. So when the agents are going through the page, you say, oh, this is something the agent actually paid attention. If that's relevant or not is another question, but you have that level of transparency, which is impossible with humans. And another one is what you mentioned. If I give 2 pages to a human, it's not going to work because the first impression is going to affect the judgment of the second page, right? That's why A/B tests are so difficult. Agents doesn't have that memory if you don't let them to have that memory. So I can get the exact same prompt, exactly the same agent, show A, show B, and inspect what was different from that. That's also completely impossible with humans, do those comparisons. So there is that. We have complications with agents, but we have unique opportunities. And the more that we advance in this project, more we are seeing them appearing. Some of them are pretty easy in hindsight. Yeah, of course, agents, you can get the same agent on A and B. That's so obvious. Now it is. When we start, it's like, no, we are mimicking humans. Let's make A/B tests exactly as humans do. And now we are like, well, there's other alternatives. And maybe there's still others that we are discovering as we go. Maybe we can start something that's not an A/B test. We call it something else.
Yeah.
Completely unique.
Yeah, so we can get into, well, yeah, Sidekick plus SimGym seems like the AI power duo. Yeah. Why don't you tell us a little bit about that?
AI plus SimGym? Okay.
Sidekick plus SimGym.
I
have a slide
SimGym and Sidekick. Who is familiar with Sidekick here?
Nice.
Okay, Sidekick is the agent inside Shopify, and it pretty much can admin a lot of things for you. It can help you find stuff. Pretty cool. It's quite mature already. So SimGen is kind of, it's not that. But we can combine them in a very interesting way. So imagine the following. I have a shop. I want to make it better, right? So I run SimGen and A/B test. SimGen is going to give me some recommendation. Okay, make this button red. So I can ask Sidekick to do that for me. And then I can run the test again, and I can loop that. I don't need to be in the loop, for example. I think that's an extreme case, right? But in extreme, I don't need to be in the loop for improve my website. Up to a point that, okay, we know that LLM goes crazy sometimes, but you start to think about like, yeah, we can have some continuous integration. One system applies, another system evaluates, and another system applies.
Carpathy research loop.
Kind of that, with two systems for shop, right?
Yeah, do you want to, so I have like I said at the beginning, I have a store, and actually one of my philosophies, because I work on Sidekick as well, is that I don't ever want to make changes to my store or like improve my store unless Sidekick can do it, because then this kind of forces me and the team to add actual real useful features to Sidekick. So I had like judge.me reviews on my store, but people could leave reviews, but I wasn't actually showing reviews on my store because our theme editor or Sidekick could not add like the judge me blocks to the store via natural language. I mean, we can now, which is why this test worked. But so I didn't even know the team was doing this, but they ran this research loop on my store, and they saw that the agent on the product pages, the product detail pages, kept scrolling down and scrolling up, and its reasoning for scrolling down was actually to look for reviews, because this is a common pattern when you're buying things online. It's kind of rare that you buy things from stores without reviews, I think. But I had a lot, but they just weren't shown on my store. So SimGen and Sidekick, like Sidekick when it was analyzing basically the traces, was like, all these AI shoppers are looking for your reviews. And then, so the next stage of it, Sidekick now has the ability to add the blocks for third-party apps. So it added the reviews and then reran the test, and it actually said that there was a conversion or an add to cart increase. And this is actually, so this was like a month ago. Maybe this isn't launched yet.
I don't think.
We're launching soon. But I just realized that I was talking. Yeah. Anyways, cool feature. But this auto research loop thing, and this is actually the theme that is running on my store right now today. And I am like, I don't have a ton of traffic, but I do feel like I've had more sales in the last couple of weeks than before. And I think it makes a lot of sense. And Sidekick's kind of analysis and change here was, I believe, super helpful. So I think this is like some very good value that we'll be adding to merchants here. That's outside the A/B test realm, but like this whole auto research thing is pretty cool. Like we've done it in a ton of places now. Yeah, go ahead.
There's two huge benefits with Sidekick compared to like traditional SimGen. And one is basically context and tool calling, and the other, I had it and I'm forgetting it. The other is just like technical capability. So a lot of the recommendations that are presented to our merchants, they might end up being more technical than they can actually accomplish on their own. But if Sidekick sees this recommendation, it's actually able to pull it off on its own. So I think Andrew could probably do it if he wanted to, but it doesn't sound like he wants to. So that's why it's good when Sidekick can.
I only do stuff when Sidekick can do it. And even before Sidekick was analyzing all of the traces and coming up with the recommendations, we used to do recommendations in a different way, right?
Yep.
Do you want to talk about maybe the difference between two and maybe some disadvantages or advantages?
That's kind of the context window issue, because like when Ronnie was talking about how you could have the same agent go to two treatments of a shop, and those agents aren't aware of each other, then you can learn a lot by comparing one agent's experience or one instance of that agent's experience against the other. But when you have a lot of agents, you kind of have to go and aggregate. You have to go and aggregate. There we go. Okay. Hello? Okay, cool. So the problem with how we were doing recommendations with SimGym initially is that we ended up calling it the broken telephone effect. So you would have all of the steps and thoughts of each agent as they navigated the shop. Then we would summarize those into a summary of that agent's experience. And then we would take all of those summaries of each agent, and then we would summarize that. So that's what we refer to as the broken telephone, because you're losing fidelity with like each step. When we introduce Sidekick into the mix, then it's able to, instead of referring to these summaries, it's able to actually like retrieve the steps that the agent took and come up with better recommendations and conclusions that way.
It's actually a pretty interesting problem too, because I think of propagation of errors. It's the same kind of thing here, and how like Sidekick as an agent helped reduce this and the broken telephone problem. But it just, like in 2011 when we were building agents or assistants, they were literally a classifier for like the domain, and then a sub-classifier within that for the intent. Like maybe it was calendar, and then create a calendar event. And these are like SVM classifiers back in the day. And then it's like a conditional random fields model to do entity extraction. So like the names and the times. And then it would go to a dialog state tracker. And then it would go to like a templated natural language generation thing. And each one of those, we always used to say propagation of errors. You know, this was when we were at the startup. And wouldn't it be great if there was just one model to do everything? So it's funny, because now that's what LLMs are doing, but they're kind of following the same process. They're classifying into a tool call. That tool call is getting the arguments to the function. So when you think about it, it actually works the same way that it did in 2010, except now we have one model that does all these things. You know, and you could create the whole startup that took 7 years to sell in like a week, but so that's nice too. But yeah, it's just crazy to think about these common patterns and issues from 16 years ago building the same thing, and just see them, you know, still be issues and still have the same solution. So
in 2010, I was just playing with jQuery, I think.
Yeah, it's crazy how fast time goes. What other are some big challenges that you think that you guys are facing?
For me, the most complicated part is the number of parts that we need to tweak to make this works. Because it's not only making the LLM behave like human. There's different types of humans with different goals, with different span attentions. So someone is just looking for the product. Someone else is like committed to find the product and buy it. It's just waiting for a deal. So it's not just like, yeah, make the LLM go and hope for the best. We need to say, okay, which types of users are there? How are they distributed? How, for this particular shop, how many people are looking for deals or for premium products? So the composition of the LLM and then the browser, is the navigation accurate, the perception of the agent is accurate, then the recommendation. So there's so many levers that we need to tweak, levers and buttons, that makes this thing complicated. On the other hand, that's what makes SimGym so valuable, in my opinion. There's a very low surface to volume ratio. The user just clicks, I want to run an A/B test, this, go. Behind the scenes, we are doing a lot of work, and that's the best type of thing to solve for the users, is that the user will think that's super simple to do and use it, and we have all the burden of making that works, no matter how complex it is.
Another one I'd add is just like reproducibility. So like when we're talking about the benchmark tests that we run, we want to see how improvements to the model or the prompt that we feed the model affect the agent's ability to navigate a shop. So we'll send it to shops that it has navigated before and see if it improves. The problem is like shops change over time. So like it means your golden data set isn't so golden at all times. So that's actually a problem that we're solving right now, trying to like snapshot shops in time so that we can have a more reliable golden data set.
You're kind of touching on, I guess, diversity a little bit, and how you talked about it earlier with like making sure you don't make the same recommendation. But how do you, there's like billions of humans I guess, in the world, and a lot of people are shopping. So how do we? You talked about a couple of things, but how do you make the AI shoppers so diverse while keep it aligning with like what we see from the 20 years of shopping data?
Yeah. Okay. Well, so let's talk a little bit of how the sausage is made.
Yeah.
Okay. So basically, we have
start hard and end hard for this discussion.
Thanks a lot. So there's this. We need to simplify the problem. We have a model, and every model is a simplified representation of the reality, but it's good enough. So how do we represent the users here? We break the synthetic users in two parts. One is the archetype. So what's this guy about? Is this buyer about ethics, about price, about quality? And then the other component is the intention. Is this user committed to buy something? Like, I want to buy it. Or it's more like, I'm exploring, maybe I buy if I find an opportunity. So with those two components, we can create a vast range of synthetic buyers. The trick is to combine the right intentions to the right archetypes and find the archetypes. We have a process like, because we have click streams and real user data, we can combine and cluster them. Then, because we don't really need, for example, if I have a shop that has, 3 million users a day, I don't need 3 million bots to mimic that. Because some of those behaviors are going to repeat between the users. So I need one bot or a few bots per behavior, which reduces that. And also the opposite. The shop has absolutely no buyers yet. It's just starting or have like one buyer per day. I can also simulate against those archetypes and see what will be the performance. So that's how we are simulating the behavior, breaking them now, and focus on what is useful and not like trying to simulate everything. I don't know, the bot has a bad day, humans have a bad day, but we are not at that level because it's not that useful.
And Sidekick comes in to help too when Sidekick is fully integrated with SimGym, because it actually knows a lot more about the merchant and about the shop. So it's able to kind of seed a lot more context into the recommendations that it's making than SimGym on its own would be able to.
Yeah, I think this kind of helps us end with, a very powerful thing about SimGym is that it's bringing this kind of capability to small merchants, not just big merchants. And because big merchants can run these things at scale, but the real power here is, small merchants can do this too, right out of the gate. So also I just noticed with my foot up that thank you, Aaron and team from the previous talk for shipping these socks to me. With that, we have 7 minutes for questions.
Maybe I misunderstood, but how do you capture the aesthetics part of a website? Because maybe arguably agents don't care if something looks pretty or not, but maybe some human buyers would resonate with the feel of a website, how to navigate it like that.
Yeah, we don't get this the feel part. We reduce that to specific dimensions. For example, this agent or this buyer wants premium products, right? So it's not a matter of taste, but taste, a specific angle of the taste, like premium versus cheap, or expensive versus cheap again. So that's how we break them, not just generic. We break the taste in some components that we can a little bit more easily measure.
I think the multimodal model would capture some of this as well.
But for example, we don't have agents like, oh, you like red, right? Or that's not part of the thing.
Yeah.
Yeah, but if the more that we can reproduce accurately the behavior of a buyer, and combine vision with that, it'll just kind of come naturally that like one theme's UX, UI might be introducing more friction than an alternative. And we would see that through the add to cart rate or through other metrics.
Yeah, I think even further, like, because I see the point of like changing pixels around, changing the colors of a button or something can make a big difference. And we would need the multimodal model to capture that. There was a question over here.
Yeah, hey guys, thanks. Thanks for bringing up auto research as well. I spend most of my time thinking about recursive self-improvement, specifically for creating new models or like running really fast inference or hardware-specific inference. So I know you're sitting on a ton of data, and I know that you have access to whatever LLM you want. Can you walk me through how you think about model selection and when you think to go to create a proprietary model, train a new one? We're going to have to serve a ton of it, so we have to get something really small. Like, just walk me through how you think about model selection and creation.
You want to start?
Sure, because I actually had some stuff here when I was talking about the auto research loop. This is I'll share this slide because I actually first presented this, I think, last year at Toronto Tech Week. So I thought I'd just share it, and I think this has just been foundational to one, how we do evaluations and simulations, but also having that kind of judge and simulator that we can trust has led us to do pretty big things with auto research on even the like fine tuning of our own models. Because like some of our models, like more of our interior models, let's say that maybe turn natural language into GraphQL, like on this next slide, these models are so great at like a huge variety of tasks, and they're very, very general. But what we're trying to show here is with things like auto research, if you want to go into something way smaller for better inference, and it's just constrained to that task, that with an auto research loop and self-healing data and constant, you can actually outperform these very, very large models, but on a very task. So you can make it better, faster, cheaper, but at the loss of this generalizability that these models just give you out of the box. So with this auto research stuff, I think it's fantastic, but I really think you need to have something like really foundational in place so that these models don't do reward hacking and you can trust them. So we have the same kind of application on SimGym and others, but it's a great question because I just think it's so important to be thinking about. Do you want to add?
And talking about models, like our priority is try to get the best model that gives us the best performance, right? In performance here, I'm saying match better what the real buyers are doing. When we reach that, do we have a cheaper model and faster model that can reach the same level or close enough? Okay, let's try that. So it's a back and forth between improve it, make it faster and cheaper, improve, make it faster and cheaper. So we are constantly changing and evaluating the models. And that's kind of unavoidable because the velocity, the speed that the models are evolving, you need a process for that thing. You cannot say, I've reached the best model. It will last like 3 months.
Yeah, you never will. Okay, we have time for 1 or 2 more questions, if we answer quicker, I suppose.
Hello, yeah. I have a question. So I do understand the SimGym actually simulates the user. And what if a new merchant comes to you, and do you actually simulate the data for them, or you have a requirement for silver or gold layer of data coming from the merchant to start with?
That's a very interesting question. We have that problem, and how do we solve it? We find similar shops that have the traffic, and you say, okay, if we're similar enough, we can use the same distribution for that. So we call them like donor shops in the sense they are donating the behavior to the newer shops.
Okay. So you just borrow the data and work over it, expecting this should be the same, rather than simulating the data as.
I think a big part of it is like just so many shoppers and creating these kind of archetypes as general shoppers, and then just throwing these archetypes of shoppers into any store is like pretty powerful.
Thank you.
One more.
Hi. So yeah, I was just like a bit curious about, like, Andrew, you just touched upon LLM evals, and Nicholas, I think you mentioned that, like, our goal here is to like make the storefront like better for humans, right? But like I think what SimGym is trying to do is like making it easier for AI agents to navigate through the store. So like just to like touch upon that reward hacking, like the Goodhart's law, like how do you actually prevent like SimGym from like optimizing for that instead of like making the store better for humans? And also I was just like curious if you've ever thought about integrating SimGym as like a sort of an offline eval layer for Sidekick. Yeah.
Do you, offline eval for Sidekick for sure, and even like this research loop that we talked about here was like using them both together. And I think more pointedly, your question is probably when we do make our theme editor, like our theme editor skill within Sidekick, so to speak, evaluating it with SimGym. I think that's a great idea. You should build that.
Yeah, and regarding like the AI trying to optimizing for itself instead of the human, what grounds that is that we do have the real human behavior. So if the LLM is not behaving like the humans, the metrics are not matching, we are not doing our job right, and we change the model.
Yeah, and just to clarify, the goal is not to make shops easier for AI agents to navigate. At least for SimGym, that's not SimGym's goal. SimGym's goal is to use AI shoppers that best represent the real buyers of the merchant, so that the merchant can make their shop better for actual humans. So like there's no recommendations that are made by SimGym that would optimize the shop for an agent. It's always to optimize the shop for a user.
I think that's it. Thank you.
It's great. Thank you, Andrew, Ronnie, and Nicholas. There's a couple kind of Shopify things that you called out in this talk. Also, one, we talk about ourselves as the entrepreneurship company, and this is what Andrew was talking about. You wouldn't necessarily build a system like SimGym if what you were focused on was charging for SimGym specifically and looking after those larger merchants, because they would pay for it, but they don't need it. So we are working on how do we get to that first buyer for a merchant, that first sale for a merchant? How do we help more merchants become entrepreneurs? And that unlocks more systems we can build. The other thing is I like to describe Shopify as a learning company, and I think this was a great example of experimentation at its best, and we're going through these loops to really figure out how all of this works. What we were talking about today is kind of the current version or where we're at, but this is like multiple years into the exploration and getting these agents to do what we want and getting into these systems. And while we do it in this context, we do it in many other contexts as well. This one's just a great example of that. I'm not going to do much of an intro here aside from welcoming Burke and Javier up to talk about dev tooling and kind of the evolution of what we've been building that's led to River. Guys.
All right. Oh, hello. Okay, let's go. Go ahead. This is not our slide deck, however.
How do we get our slide deck on the screen?
So we, when we originally pitched this talk, whoops, let's go back. All right. We thought we were going to generically talk about developer tools at Shopify in 2026 because we weren't sure if we could talk about River publicly yet, but now we can. So we're going to talk about River.
So the reason we can talk about River is because Toby 2 weeks ago, published an essay on X about the philosophy behind River. And then after that, it was like green light for us to start talking about what we did and how we did it. This is a work that happened in the last 3 months, more or less. We started River on St. Valentine's weekend. It was the right moment for River.
So as you can perhaps imagine, this is a very strange time in building developer tools. I have been at Shopify for, I think, 14 years now and been working on developer tools for most of that time. And the new thing to be doing for developer tools is very different from what it was. We have this, Javier just talked about Toby's essay, but I want to rewind first prior to River to talk about some decisions that kind of led to River. We'll talk, I'm sure most of you haven't seen this essay, but we will talk more about what River is. But first I want to talk about some decisions we made in spring of 2024. We were all, the entire company was gathered around a big conference center in Toronto talking about the future of engineering. And we decided that day that we were going to go all in on a monorepo for Shopify, which is a huge engineering challenge. This was a big bet. We also decided that same day we were going to build our development environments and a few other things with Nix. This entailed a lot of work, and it's been happening for the 2 years since then. But the reason we did this was actually, it was actually an early bet on this idea that at some point in the medium-term future, from the perspective of spring 2024, pretty much all of our code was going to be written by, we didn't have the word agents at the time, but we gestured at LLMs. And this felt like something that wasn't as obvious at the time as it is today, but Toby was very sure, and we all agreed with him after thinking about it for a moment, so we went and started building that.
When was Devin release?
It was around that time, yeah, but we used it and
so we used it for like 3 days, and we were like, this is shit, but this is the future at the same time.
Yeah. I gather it's improved a lot since then. So the consequences of this decision were manifold. The idea of moving to a monorepo sounds nice, and then you confront all of the things that you have to do to make that real. I think moving to a monorepo is coextensive with basically a commitment to rebuild all of your own tooling. So we had to scale CI dramatically. Merge queues suddenly became a big problem. Build caching, test infra, lots of little assumptions. There was a lot involved in dealing with this decision we made. But even relatively soon, we got a few things out of this. We got, you can just open Claude Code or Codex or Pi or whatever at the root of the monorepo and start to interact with all of Shopify's universe of code, all in one go. This started to feel powerful for the people that figured out to do this. We can have skills that span the whole universe of our code, ask the entire monorepo a question. Some of these things really started to stitch together in an interesting way.
So, as I said, February 13, we released River. We had worked on it for 3 weeks or so before that. Right now, 1 out of 8 PRs in our monorepo is co-authored by River. Almost 6,000 people have used River so far across 4.4K channels in the last 30 days. River only works on Slack. Let's talk about River now.
Yeah.
Okay.
Well, we can, go ahead.
No, go ahead.
Yeah. So you can tell we prepared great for this. So there's a thing that you get confronted with when you start trying to run agents more in your code base. You realize all these little things that it's just not really getting about your code base. There's all these little pieces of knowledge and all these systems that you kind of realize upon reflection that you've been jumping through these hoops or holding all this context in your head that's never written down anywhere, and you try to onboard people into this project, and you're like, oh, wait, hang on, I actually have to explain these 12 things to you before you can interact productively with this. There's a thing that I think is true, that like all of these steps everybody is going through right now to make their code bases more agent-friendly, it's the same thing as making them more human-friendly. We just, for whatever combination of reasons, haven't really until this point prioritized making these things self-documenting, self-describing in the way that we're now discovering is not just important, but critical. This is going to be true everywhere, right? Like, The development environment isn't reproducible means agents can't reproduce it. Repo's fragmented, agents can't figure out the way they relate, the way the pieces relate to each other.
And then here comes the thing, local agents have a ceiling. When you're working alone, you are limited by your ability to handle this agent. And the truth is, and this is something that people try to avoid saying, none of us know how to use these things. I was reading the Pope encyclical yesterday, as we should all these days. And he was saying something interesting. He was saying that the way we approach these systems is as if they were plants that are growing, as if they were living systems, because in reality there is very limited control about what we don't know what they are. And so when you work locally, when you work on your own, you are limited by your imagination. So there is something that you can gain out of just like collaboratively engaging with these things. And so that's what happened here. Go to the next one.
Yeah. So when every interaction with an agent happens in a private window, the only person that learns anything from that is the person sitting in front of that agent at the moment. This was in Toby's essay that he published, I don't know what it was, 2 weeks ago now. And this is super true. Like, you see I'm sure loads of you see this in your companies, is everybody sitting in front of Claude Code or Codex or whatever on their own local machine. You'll often see duplicate learnings that everybody has to go through, and they figure it out in their own context, but you're sort of wastefully not sharing that learning.
So River enters the game. River lives on Slack. It's a presence that is in any public channel on Slack. It reads code, it runs tests, it opens PRs, queries data warehouse, etc., etc. It spins boxes with everything in it very, very quickly. It operates across the whole repository. It does it really, really, really fast. And is very efficient at using tokens, etc., etc., etc. But the most important thing is that it effectively creates the learning environment that we need to learn how to master these things.
So to just drive that home, you can only use River in public channels. And once a thread is started with River, anyone can contribute to that thread. So a thing that kind of surprised us is how much, we thought it would be valuable that we would have this kind of osmosis learning thing of seeing someone interact with River and everybody learning from how we use the agents and seeing, okay, well, this person knew these things about this system and I'll internalize them. The thing we didn't anticipate is how much value people would get out of like directly multiplayer experiences, of like actually kind of going back and forth and maybe even only tagging River into a conversation like 30 messages into the thread, right? You can have this debate and then say, at River, what do you think? And River might decide that she's going to agree with one of you with some caveats for the other one and offer to open a draft pull request to just implement the thing you were talking about. It's kind of incredible.
And then here comes something important, because River works in the open and only in public channels. We can afford to do this thing of recording every session of River in a place that River can access. So River has self-awareness in that sense. And it can review previous conversations, it can learn from whatever it has happened before. We have jobs that go over previous sessions and try to improve River so that River is better at doing things that may have failed doing before. And people on their own are also learning from all these things. So everybody is contributing to River, and River is making everybody stronger at the same time. That's kind of the game. Have you ever seen the series The Pit? The Pit is like the most beautiful example of a learning environment that is active. And I think that's what River is allowing us to do, is forcing everybody in the open to play the game. There is a channel where you can see Toby working using River, and people can jump into that channel and collaborate with Toby on solving things that Toby's worried about. And everybody's doing that more and more, and we are learning from each other, and there are some people who are very, very good at this. There are some people who are not as good, but they are learning. Some people have very, very specific expertise, and they all can collaborate into making both River better, World better, and the whole organization better.
So let's go to a live demo.
What do we want to show?
I'm actually gonna first show you this little video that our teammate Surma put together.
This video was actually generated by River. Fun fact. And most of these messages are actual messages to River.
This one isn't.
This one isn't. Our teammate Surma made this video with River. What were we going to say? Well, I think I want to add something here that maybe is relevant, which is that I think in the previous session we talked about how it's important for us to use our tools. The River team has been using River very actively to build River itself. Over the last 3 months, we have had, Bert, can you try to show that thing?
Yeah.
So this is something that I asked River to create like 10 minutes ago. We have created 922 pull requests with River, out of which 441 have been merged. There are 125 open.
And this is specifically pull requests authored by River on River.
On River. On River and the infrastructure underneath River. One of our teammates, Christian, has created with River, and I think merged like 200 of these PRs.
Yeah, 165.
165. So we are really committed to using River to build River and to build Shopify.
Javier, River hasn't figured out the by the week chart yet.
Yes, River is stupid as well.
Oh, that's too bad. Yeah, so I'll show you just like, I did a smaller demo last night, and I'll recap the little thread I showed there. So this is like an actual example of a real River session. So I just asked River to build a little architecture diagram for River, including the new infrastructure layer that we're going to talk about in a minute. Post it somewhere on Quick. Quick is just a little like, I don't know, internal hosting platform thing we have. I think we're talking more about that publicly next week. It's pretty, actually quite cool. But anyway, River surveyed the monorepo because every River session runs with a just transparently full clone of our ridiculously large monorepo, and threw up an architecture diagram. But because we're like halfway through this transition from the initial fairly crappy architecture we built for River to like a much more intentional one, it kind of keyed on the old one. And so Javier and I redirected in a multiplayer way towards the new one. And River said, oh, okay, sure, fair correction, here's the new one. And I can pop that open. This, I don't expect you to internalize too much right now. That's a whole lot of boxes. But all this to say,
But something that maybe is nice to highlight about that particular arch diagrams Quick is that arch diagrams is like a site that Toby created with a generic agent skill that generates this diagram for any repository, and then we incorporate it into River in a matter of like a few hours after it was created, so that anybody could create these diagrams very quickly using River and not having to open Claude for anything.
yeah, so we're going to not click that all diagrams button because that would be ridiculously proprietary, but we can show you this one.
Because we're going to talk about it.
Yeah, that's probably it for the demo right now, right? Maybe back to the presentation? Yeah.
Let's do it.
What's next? Yeah, so we sort of lightly showed this in that thread I just showed you, but yeah, this multiplayer thing, super powerful pattern. So there's like, if we zoom out for a second, there's this way that I think is really important to think about our monorepo, which is that River is a part of our monorepo. All of the context we provide River is a part of our monorepo. All of the intelligence we put into World, our monorepo, is part of this system. And we use that system to transform itself more and more autonomously, right, as time goes by. So I think it's really important. We're approaching this quite intentionally, and I think this is going to be kind of true for a lot of these sorts of systems in the future. Thinking of our monorepo as this self-transforming system that has its own intelligence layer built in. And River we kind of think of as the little persona that we plaster on the front of it, the animating spark of that intelligence.
One of the ways in which this has manifested very explicitly from the beginning is that people come to us and they are like, how did you guys manage to nail so well the voice of Shopify with River? What was the magic here? And then I showed them the system prompt that I wrote like 2 weeks in, and it's like the most stupid system prompt you can imagine. It doesn't sound like something that could capture the voice of Shopify quite well. It's kind of quirky. It's not really something trying to do that. But the thing is that River not only has access to that system prompt, it has access in context to the whole Shopify. It can see all the Slack conversations. It can see all the code, all the comments, all the PRs, all the conversations, et cetera, et cetera, et cetera. When you give a robot like this access to that level of knowledge, even if it's unstructured, the robot is going to start speaking your language. And it's not only that, it's the robot has awareness of the organization. The robot has awareness. I'm being like a little bit, awareness doesn't make sense for these robots, but like, you know what I mean.
I think an important mental model here is like, in one way of conceptualizing it, which I will relentlessly advocate to anyone who will listen, World, our monorepo, is Shopify, and River is World. Therefore, River is Shopify to a significant extent.
River is like a verbal manifestation of Shopify.
So almost immediately, once we launched River, people saw that, and they said, wow, I have this great use case. I want to do something super similar, but I haven't been able to build the infrastructure for it, and yours seems like it might work. So why can't I use the River infrastructure for pull request review, for research agents, migration agents, compliance scans, performance investigations? A lot of those things are possible in River, but as soon as you want more automation. So we didn't really have a satisfactory answer, but Toby really felt like we should. So we built a platform, or we tried to build a platform. I was kind of struggling with this for a few weeks and just like trying some iterations, and nothing really felt like it was clean enough. Everything felt like it wasn't quite working. But then we stumbled across this one insight from Anthropic actually published a blog post, just like immaculately well-timed for us, called Scaling Managed Agents. And they had this one insight that just unlocked everything for us, which was decouple the brain from the hands. So what this meant was basically, well, okay, yeah, what this meant was basically, you should separate the place where the session runs, where you run your harness, in our case it's Pi, but whatever it is, from the place where your code, your artifacts live, and link them over a network boundary with like a tool called proxy. So now we're able to decouple, we call them sandboxes, where the monorepo clone lives, and cells was the noun that Claude invented and I never chose to rename, for where the runtime harness lives. Also, fun fact, just apropos of absolutely nothing, River wrote the slides for this, and you can tell because it's using Claude's favorite font. So the platform that we built is called Aquifer. This is the thing that's underneath River that makes River work beyond its initial
And
incarnation.
by the way, the fact that we named this thing River has created a proliferation of new water-related words in Shopify for every single type of things. And we are abusing this thing in all the possible ways.
River, by the way, is actually the metaphorical meaning is I think pretty significant. The connection is rivers shape the world. So world being our monorepo, river is the thing that continuously resculpts its surface. Aquifer is the source of all rivers. Or not all, but yeah, you know what I mean. Yeah. It's a metaphor, okay? So the session is the thing that has to survive. When you run, in particular, you start running agents in Slack, you have this cluster of services powering it. You're not just looking at a Pi or a Claude or a Codex process on your local machine. You want to be able to restart that service and not have River suddenly stop responding to you. That's a bad experience. We had that for a long time. I was happy when it stopped happening. So the significant thing here was pulling the session transcript even further out of the system to be database tracked so that you can just kill one of these Pi sessions and have it immediately reconstitute its transcript from the database.
I read that, I read somewhere, I think in Reddit or like in X, that in San Francisco, people are working with their computer, are walking around with the computers like this, because they have live sessions here. So we build this thing so that we can do this.
Big quality of life improvement.
Mm-hmm.
Probably good for laptop longevity too. So yeah, this just to reinforce that design split. The session is this almost abstract thing. It's not really modeled by a process on the machine anywhere. It lives in, literally, it's a Postgres database. The agent loop it can be a fairly ephemeral process that loads in the transcript to date and starts running agent turn responses, sending the responses via the Slack message tool generally, but it can be whatever in Aquifer. And then we have a sandbox on a different machine. Yeah, the session can be, or the cell can be fairly ephemeral. So River then is just one profile on top of Aquifer. It's certainly the premier profile, and it's the one that we put by far the most effort into, but the idea now is for this to become a platform that we're able to run River on. Profiles are just data, a prompt, some skills, some Pi extensions, defaults, sandbox policy. Everything in this world is Nix, which is so operationally simple. It is wild how good GPT is at writing Nix code. That's a whole other presentation that I actually kind of gave at Planet Nix a couple months ago, if anybody's super curious to dig into that.
But something that I think we haven't mentioned and we may have missed in the slides is that we are building River and Aquifer assuming that the future is very hard to predict. And also assuming that we are probably wrong about the majority of the decisions that we're making right now. So River and Aquifer are by essence very, very flexible, and we are very, very willing to reconsider most of the decisions we have made so far. Aquifer, as Burke sort of suggested, was born out of like reading the Anthropic paper and being like, these guys have something here that we want to capture. That was a month ago. So a month ago, we decided, let's just do one more re-architect of this thing after the two previous re-architect that we did in the previous 2 months.
Just one more re-architecture,
Just one more re-architecture.
Just one more.
And we keep saying to people, hey guys, just so you know, this is not the last one. We are going to continue playing this game because we don't believe that this game is something that we will master at the first shot. We are still learning. We are learning how to learn, and we are learning how to learn how to learn, and so on and so forth. This is very recursive everywhere.
Should we let's jump back to the laptop for a second. I have another thing we can show you here. So let's go to this tab. So this is the little, like, I don't know, demo, whatever, site we built for Aquifer. So This thing actually, the API for this is ridiculously simple. So we have this isn't like, it's kind of a gloss of the code, but you can see if you want a chat session, I'm going to say, oh, I had a great demo for this and I wish I could remember what I wanted to type. Okay, yeah, okay. So let's just say, tell me about your sandbox shape. So that'll run for a sec. This site's kind of janky because Claude wrote it all in like 5 minutes or whatever. But the agent, oh, well, I don't know. Okay, whatever. Let me try again. Tell me about your sandbox shape. All right. So we're going to do some tool calls. These are really not beautifully styled on this. We can't emphasize enough how much I did not spend time making this chat interface look good.
One of the things that we are thinking, like future thinking here, is we are thinking that the machine in which the robot is operating can change configuration across the session because at some point the session realizes that it needs more resources. So that's the reason the box is like a parameter. We want to be able to say at some point in the middle of a session, you know what? This box is not the box we need right now. We need another one. And then poof, another appears.
I'm going to get River to fix this. This thing kind of sucks. The chat interface doesn't do markdown rendering, and it does this like janky refresh fade in thing every time I get a new packet from ACP. Can you just fix that and like redeploy it to Quick and open a draft PR for me?
This may take a while.
Probably I want a PR, not a VR, but you know. Okay. Yeah, anyway, so River will do that, and sometime probably shortly after this session is done, this will be much better. Yeah, so I don't know, that's pretty cool. So it tells me about the sandbox, having done some tool calls to investigate it. It's like, you know, Linux, NixOS based, we've got some resources, whatever. Yeah, anyway.
Again, it's sort of important we give these agents self-awareness about the system where they are living. We want the agents to know what they are.
And you can see too, if you look in the generated code pane, this is like pretty much the code that would actually work. You get this like cool little aquifer.chat thing, specify a profile for it to run in, and then from any, in this case, QuickSight, you can just respond to chat events. Insanely simple. And we have a couple other APIs for like generating a semi-persistent sandbox or just running a one-off job in one of these sandboxes. So this is going to be like very influential in the tools that we build over the next, I would say year, but who knows what happens a year from now. Let's say quarter. Yeah, back to the deck maybe.
Yep.
So. Yeah, so like on that point of like things that we can enable with this, right? Like it's fairly easy to imagine doing like an automatic PR review thing with this same infrastructure now. So having agents that just come up using the same Aquifer infrastructure and like automatically review PRs for us, maybe propose changes to us. Like maybe we could build something that has a one button click to accept or reject a diff, I don't know. CI, we could build in the same thing, right? Because if you have suddenly an ephemeral sandbox where you can have your whole monorepo available, maybe that's a great way to build CI. Any number of things, right? Like this is something where I'm super curious to see what the rest of our organization comes up with, given this, this infrastructure. So, this is a quote that Claude put in this thing, and I'm trying to figure out how to. So Toby said, the speed of an organization is determined by the speed of its lowest bandwidth communication channel. And so the thing that I think is like really significant about River as a technology is it just closes all these communication loops, right? Like you get suddenly a thread that pops up in some channel, and the distance between like tagging in the relevant people to hash out some kind of like initial exploration of a solution and then just tag River to complete it is narrowed to zero, and the activation energy has basically dissolved.
People don't need to prepare dev environments in their local machines. People don't need to think about how to set up services. People don't need to think about all sorts of considerations that sometimes you need to think when you open your machine to start working every day. I can open, I am doing this more and more. I take Uber from home to here. I open my computer. I know that I am not using that much bandwidth on my phone because I am just using a Slack, and I start talking with River on Slack. And by the time I arrive here, 15 minutes later, I have a PR open. Easy.
So this is all just starting, right? River shipped about 2 months ago, which is kind of incredible to think about. It feels like forever already. At the time, I put this slide deck together, which was like days ago. Aquifer was just rolling out. Now, I think we're like a day away from deleting the previous infrastructure because that's how fast things move now. And yeah, I don't know, like next time you see us in public, we'll probably be talking about a completely different set of things that we built on top of this.
We actually don't believe that River in its current form is going to exist for much longer. We're gonna evolve this thing. It's gonna become something that is probably less visible and more active at the same time. But at the end, this infrastructure is what is gonna persist and continue evolving and keeping us at the edge and like really pushing what these models can do.
But if you want to find out what's next, you can come ask River yourself.
There are talent people all around. Please talk to them, and if you want to play with us, just chat with us.
Questions? Yeah, is River something Shopify is selling? Definitely no. You can come work here to use it.
We are not selling it because it's our system for building code. But we want to talk about it because we believe that the learnings of these are applicable to many more companies, and it's important for everybody to gain. We feel that we are very privileged. We have been in a company that has embraced these models very, very, very early, and we believe that everybody can benefit from learning what we have learned so far. So we are very happy to chat about this thing and like explain how it works. How do we choose people?
So many options.
I don't know how to choose people. What?
Right near you. Yeah.
Okay, that's unfair. You shouldn't choose the people in the front.
Okay,
That's
well,
just
we'll pick
bias.
somebody definitely not in the front after.
Okay.
Next time I'll try to sit a little behind.
Dynamic.
But it is very impressive to see the speed and the scale with which the River is evolving. I had one question about one thing that we mentioned in the start, that the River also has knowledge, and it keeps storing knowledge about the decisions and the conversations that keep happening previously in one place, and tries to use that knowledge and apply that knowledge in the other place as well. So in this case, I wanted to ask, some teams work differently and take decisions differently based on different management styles or like different parameters. So how does River also weighs that in?
Okay. So my friend Angela here, Angela, raise your hand. Angela developed a system that is part of River that allows for teams to configure their own River in their own channel. So when you go to your team channel, you have ways of parameterize River, even at the level of the system prompt, at the level of how code is written, et cetera, so that River accommodates a little bit to the style of the team.
I will say in addition to that, which has been working well, a lot of the project of the monorepo too is minimizing the amount of team-specific workflow configuration too. So it certainly exists, but the long arc of this project is to try to homogenize things a little more.
In addition to that, we are, of course, encouraging people to use agents, MD files, skills, etc., that are localized in particular zones of the repository. So when River arrives to a zone, it dynamically loads the skills and the context from that zone and knows how to operate on that zone in a way that is compatible with the requirements of that zone. We also use it for like completely stupid shit. Like there is a Slack channel called Evil River in which River is evil. And there is one in which like it only talks about chocolate chips, and recipes for chocolate chips, I think. Cookies, right? Yeah.
Okay, let's do one more quick one. We went a little long on the presentation.
One from like the back. You, well, yeah, that person.
Yeah, so I have a question because I use Toby's repo QMD quite a lot for my own like personal knowledge management. I was curious, like, does that influence like any of the decisions in River? Because I see Toby basically committing to it on the weekend as well. So.
Yeah, we're like actually we're like actively working on the memory system like right now.
Right.
So that's definitely one of the things that's heavily influencing us. It's like in contention for direct use, but certainly it's influential in our strategy. And yeah, I think we are done.
We're done. Thank you.
Thank you, Burke and Javier. There's a lot of good stuff in River. If you're thinking, hey, you don't need to be a software developer to use River, you're absolutely right. And people across disciplines are using River to create PRs. If you're thinking, hey, River created that video, it can do a whole bunch of things that are not really software related at all, you're also right. It's completely changed the way we do like basic data science and initial explorations. You'll find things where before you would have taken weeks to get an answer, you're getting directional information almost immediately within 10 minutes, which is quite amazing. The other kind of, I like to pull out, maybe you can tell, kind of a Shopify thing from this. Shopify's forever had this kind of approach where if you wish the system or the world would be a different way and you have the ability to do it, before we were only constrained by the amount of time that we had, and so we had to pick selectively what we would do. Now we just think that we're not actually constrained in that way, which is why we're rewriting River multiple times. We apply the same approach to many different systems, some of which we'll probably write about on the blog as we go through some of the major architectural changes that we're making, because we now have the capability to do so. So that's the end of the talk portion. We're going to move into the fireside chat, but maybe by show of applause, how have the talks been so far? Yeah, I mean, one of the really nice things about putting together an afternoon like this is I basically got to pick what topics I wanted to hear about, and mostly I thought if I was sitting in your seat, what would I want to hear about from Shopify? And that also makes its way into this fireside chat that we're going to have. So let me introduce our speakers who are going to talk a bit about quantum computing and maybe get into some other topics as well. So Farhan is the VP and head of engineering at Shopify, where he leads, I think, one of the greatest engineering organizations in the world. An engineer and builder by instinct, Farhan joined Shopify through the acquisition of Helpful.com, where he was co-founder and CTO. Before that, he served as CTO of mobile at Pivotal and VP of engineering at Pivotal Labs. Earlier in his career, Farhan held senior technical roles at Achievers, Microsoft, and Trilogy. Beyond Shopify, he is an active investor and advisor to startups in Toronto and San Francisco, including as a mentor at Y Combinator and First Round Capital. Farhan holds a degree in computer science and electrical engineering from the University of Waterloo and an MBA in financial engineering from Rotman. Christian Wiedbroek is the CEO and founder of Xanadu Quantum Technologies, a quantum technology company building fault-tolerant quantum computers using light. A physicist by training and entrepreneur by instinct, Christian has spent the last 20 years at the forefront of bringing quantum technology to the world through his research and leadership in academia, government, and industry. Christian holds a PhD in physics from the University of Queensland and held postdoc positions at MIT and the University of Toronto, our local university, or one of them. Under his leadership, Xanadu has grown into one of the world's leading photonic quantum computing companies, backed by over $250 million in funding and recognized globally for its innovations. Guys, please join me on stage and take your seats. I'm really looking forward to this conversation.
Check, check. All right. You might have to turn it on.
Testing.
Okay, that's good. Hey, welcome, Christian.
Thank you for having me. I appreciate it.
Cool. And thanks for everybody to be here, because it's always fun to do Toronto Tech Week and obviously bring lots of people to Shopify. And thanks to Lawrence for moderating and all the great speakers so far. And specifically, Christian was my #1 pick for this fireside chat, because obviously what you're working on, quantum computing, is now kind of coming more into the main stream, given that it's been coming for a while, right? Like AI has been coming for a while and everyone's talking about AI, but quantum's something completely different. So I wanted to kind of start off with what does Xanadu do? And then I want to get into like how is it different from other quantum computing companies? Because we've seen like what comes out from, Google posts something about what they're doing in quantum, and IBM, and I think D-Wave, and then Rigetti Computing, and then now you have a Xanadu, which is a different approach.
Yeah, for sure. So what we do is we build quantum computers. It's that simple to say. Very, very hard to do. And you can build a quantum computer out of two kind of particles, either photons or electrons. What differentiates us from nearly everyone else is we use photons or light, lasers, to build our quantum computer. We recently went public as the first pure-play photonics quantum computing company. And the other public companies and most others in the industry in the private sector use electrons to build their quantum computer. So that's the key fundamental difference, and there's pros and cons on depending how you build, either photonics or electronics. You can think of D-Wave, as you mentioned, Google, IBM, Rigetti. They're all using the electronic-based approach, and we're using photons. The great thing about photons is we can operate predominantly at room temperature, which is a really cool fact. And
well, not cool, room temperature.
Thank you. Yeah, it's a really hot fact, and it's what's great about that is that you use far less energy. So everyone needs cooling. So we do as well, but we need far less. In fact, the qubits, which are the quantum version of a bit of information which we process and compute with, our qubits are at room temperature. They're also acted upon by a set of gates, logic at room temperature, and the measurements at room temperature. So that saves us time and money, and also allows us to think in the future, different form factors that we can have. Imagine if you have a quantum chip in a phone, you'd have to carry around a big cryostat to the beach, So we can kind of remove that. We can also work with large-scale foundries as well. And then the ability to network together. So the ultimate vision, regardless of whether you use electrons or photons, is hundreds of individual, say, server racks, where you've got your modality of choice in the server rack, and you have to network them together, very much like a normal data center. So networking it comes for free, so to speak, because you have to connect using fiber optics, and we can use the same photons we're computing on. So it's an incredible technology overall, independent of how you build it. We like to point to one of our quantum computers called Borealis. It solved we chose a very hard math problem, a very complex system that would have taken the world's fastest supercomputer at the time. I think it was based in Japan. It would have taken 7 million years to solve, and that's assuming you were using 7.3 million GPUs, 24 hours a day. It would take 7 million years. Our quantum computer, Borealis, solved it in 2 minutes. And now it's taking those big demos showing quantum computing works, but then moving it towards applications in pharma, materials science, drug discovery, many things.
No, it's amazing. And I think as you mentioned, one of the interesting things about those other approaches is that when they need to be cooled, they don't just need to be cooled, they need to be super cooled, like as cold as deep space.
Yeah, it's actually, depending on the approach, you have it, space is around, I think, 2 Kelvin or so. These ones have to be millikelvin, so 1/1000th of that, which is crazy. Thankfully, most of our stuff works at, say, 300 Kelvin room temperature. And and it really is, the reason why everyone needs to cool down, depending on how much, is it's really fascinating. Like if you take anything in this room, like say this table, water bottle, you zoom in, you get, zoom in more and more, you see the molecules, you see the atoms, and then we start playing around with photons and electrons. The laws of physics are very different there. That's described by quantum physics. You want to cool things down because it's really wild. You need to be able to program or control those systems, but we're the ones programming it. And so what that means is we need some way to connect to it. But our world is just so different from that world, meaning you can disturb it by doing anything. Even looking at it, if a laser shines on and hits your eye, you're disturbing the system. So, we all need cooling to sort of settle it down a little bit. But the fact that, I was reading I love reading about the first 25 years from 1900 to roughly 1925 of quantum physics. And there was still debate during that period of whether atoms existed. Like, that's wild, right? Like, and there was someone, I think Boltzmann or someone I was reading, like, he said something like, you're right, but if you can control individual atoms, that's right. And now we're controlling not only individual atoms, but individual kind of electrons, individual photons. And that's, we celebrated 100 years last year of quantum physics. So, but it's just under 100 years of the uncertainty principle and Schrödinger's equation. So it's wild how far technology has gotten us in a very, relatively speaking, short period of time.
Yeah, no, it's so interesting. I think it's still super early. Like, actually, just want to do a little survey of the audience. Who here understands what quantum physics is or quantum computers and what they can do? Because I feel like maybe we should do a little bit of an intro. Okay, not that many, so maybe we should do a little bit of an intro.
Wait, I don't know if you noticed, my hand didn't go up. It stayed firmly down.
We would like someone to describe it to us, but maybe it's worth starting from the beginning of qubits, where they're not so a bit in computers is a 0 or a 1, and a qubit has many states within the 0 to 1. Maybe it's worth explaining to folks, and then let's talk about some of the applications.
Yeah, so if you zoom in, as I said, and can control quantumness, so electrons and photons and the particular properties of these things, if you can create things like entanglement between two or more systems, if you can leverage interference and superposition, then you're off. You can kind of do some weird stuff in like these 7 million years down to 2 minutes. So you need those properties to be appearing and leveraging them. Then the next thing, a traditional computer like our phones, these screens and PCs, same with quantum computers. You have three main stages. You have the input states, so that would be bits, zeros and ones as you mentioned. Then gates, you'll apply a set of gates to sort of essentially, you've got an algorithm, whatever it is, the right sequence of gates gives you the output, and the output is the measurement or the extraction to give you the answer. Quantum computing works the same way. You've got the inputs, which, as you said, are quantum bits or qubits. Then you've got the set of logic gates. So you've got a universal set of logic gates like in classical computing. And then you've got the measurement where you extract out the answer. And the way you set up the logic gates, you're leveraging quantum algorithms that can do really cool stuff. And you leverage them. You're going to have to entangle them at some point. You're going to have interference. Basically, you can get all these answers that, or possibilities of the algorithm, the output, and you need to somehow interfere them to suppress or reduce the wrong answers and then kind of spike up the correct answer. So that's kind of how it works. And then the other key thing, as you mentioned, is 0 and 1. If you just can take one bit of information, you have a 0, a simple gate is the NOT gate, so 0 to 1, and you've got the NAND gate and AND gate, you've got many things. And then if you do the second one, you got 2 bits, 0, 0, or it could be 0, 1, 1, 0. But you just fixed at what you can put in. Now in the quantum bit, you can have a superposition of 0 and 1. The classical easy way to say it is 0 and 1 at the same time is another common way of saying it. And so you can put in 0 plus 1. Now that's kind of cool because instead of just putting in 0 or 1, you put 0 and 1. And that's really not too much benefit, but it scales exponentially. So let's say you've got an input of 8 bits. So that's 2 to the 3. So you've got 3 options. Let's say the easiest one, 0, 0, 0. Classically, you just put in 0, 0, 0 and keep on doing whatever you want. Quantum physics now allows you to put in 8 inputs, 0, 0, 0, all the way to 1, 1, 1, all combinations at the same time. And now you have gates that are acting on all these things at the same time. Yeah, it's just really fascinating. And the trick is, and then the challenge is, how do you do it in a error-correctable, fault-tolerant way? Because as I mentioned, our world really messes up this world when you try to kind of get in and probe it.
Yeah, and so as you're building these quantum computers, where are we today in terms of the number of qubits for the different styles? Like, is photonics ahead, behind, the same as what we see in the, I would say superconducting style quantum computers?
It's a really hard question to answer, and the reason is the media initially start off by saying number of qubits is the key thing, and it is. But then it's only one aspect to really care about. There's many other sort of specifications, and so They're kind of now saying things like number of physical qubits compared to logical qubits. That's a better development, where physical qubits are kind of the noisy qubits, and the fault tolerant, the logical ones are the better versions, and you have redundancy there, typically 1,000 or 100 to 1 of logical to physical. So that's another parameter. And another parameter is error correction models that you're using. There's just a whole ton of them. So to answer your question is quite difficult. I would say everything has certain things ahead of others. So we've really mastered the networking side of things, which is what others are kind of delaying to the end, because it's very hard to network electronic systems from a quantum point of view. And then other folks are ahead of us when it comes to logical qubits. But then not too far ahead, because then you've got 5 other or 6 other parameters when you say how many logical qubits. So I would say the answer really depends, and it's hard to quantify. It's not hard to quantify, it's just you've got so many parameters to quantify it. But I would say that all of us in the industry now have small quantum computers, and over the next 3, 4, 5 years, it's about getting to 100,000, up to 100,000 physical qubits, and hundreds up to 500 logical qubits with certain error rates, which is another key parameter. We aim to have that by 2029, 2030. And that's sort of put all together into what we're calling a quantum data center.
Okay, so that's pretty scary then for crypto, right?
Yeah.
Like for cryptography. I don't mean crypto the currency. I mean cryptography, SSH, SSL.
Yeah, cracking that.
Yeah, because 500 like logical qubits, like you basically now break most. Well, it depends. You get to 1024.
It depends. You'll need for 1024 and 2048. You'll need that many qubits, good qubits. So it's still a factor of 4 or so off. But having said that, to solve something like say 2,000-bit RSA key, a few years ago it was thought you'd need 20 million physical qubits, and our goal is by the end of this decade up to 100,000. So it's like we're far off.
Yeah.
But now Google and others are now bringing that 20 million physical qubit count down.
With new quantum algorithms, basically?
Exactly, yeah. And I think we're at somewhere from 100,000 to 1 million now, so orders of magnitude decrease. So if that keeps going, then we are getting closer. So it's just a big question mark.
Yeah, so maybe for the audience here, like as Christian described, right? If you're trying to like figure out the factoring of 2 numbers, and in the classical sense, you have to do that in sequence, right? Like try the different numbers, you use different algorithms. There are nice algorithms to do factoring, but they're not that efficient. But imagine you can impart the entire state of the 2 numbers actually as it's already multiplied together, and now using quantum algorithms actually factor in parallel, you can now come up with something like, hey, here's a large number, here are the 2 factors, and it can come out maybe in minutes or hours, versus now it's like the time of the sun's existence.
Exactly right. And what's fascinating is, this is really fascinating, is no one knows if there is a classical way to do it efficiently.
Correct. We don't even, right. So it's possible there is actually
possible, but unlikely,
Yes.
but definitely possible. Mathematicians have been interested with this problem for hundreds of years.
Right.
And it's kind of interesting, like our whole internet security is ultimately based on something we think is hard,
Correct.
but we don't know.
And you mean sorry, NP hard, like mathematically hard.
Mathematically hard to solve, in this case, as you mentioned, factoring. So it's been built on since the 70s, when it was first, RSA was roughly developed around then. And then our internet was built on in the 90s and today. So it's kind of fascinating. It's built on something we think is hard. Of course, in 1994, it was shown theoretically that if you had a large enough quantum computer,
Yes, you can solve it
you can
quickly.
solve it. So that was kind of an interesting counterexample, which is kind of cool.
Yeah, it was like a polynomial factoring algorithm.
That's right, yeah.
Anyway, sorry, we're nerding out here. I want to make sure we get some questions, because we want to make this interactive. So if folks do have questions, I see people nodding. So maybe you can get some mics to them, so we don't have to wait till the end, because I think that it's interesting to kind of interject as you are describing things. When you say small quantum computers that we currently have, while we get the mics over there, how small are we? Are we talking like this? Is it like a room? Like how big is a small quantum computer?
Yeah, that's a really good question. So if you take what Xanadu has done, we have 4 server racks, roughly 7 foot high, and that's one of our quantum computers. Another quantum
Or big refrigerator things, okay?
Yeah, and the earlier one was a single server rack.
Yep.
I would say roughly that's what
And it's
Most
because it's photonics. It's like it's got like optical cables in between.
Yeah, there's in this case they're yellow optical cables.
Okay.
You see all these yellow cables going everywhere.
Why does yellow matter? Sorry.
It doesn't.
Oh, okay, you just mean
could
that's
have
how it's...
been. Yeah, it was just the particular casing that we used.
Okay.
But when you do see the picture, you see a lot of yellow everywhere, and
Okay.
it's the fiber optics. And the photons are getting computed downwards from top to bottom in each individual one, but they're also talking or connected to each other at the bottom. You see the yellow cables too, but they're small in that sense, and small. There's many factors as we said, but say hundreds of physical qubits is where the industry is at the moment.
Hundreds of physical qubits. Okay, cool. Question. I see your hand up there. Oh, here.
Yeah, because we were talking about these quantum computers being able to break traditional encryption algorithms, but so I don't have too much of a background in this, but how does the quantum resistant algorithms kind of factor into that?
Yeah, even though quantum resistant is basically a set of different mathematical problems that a quantum computer can look at and have no idea how to penetrate or crack. So there's what's called quantum safe or post-quantum cryptography startups and other folks working on this, where they'll swap out, they're starting to now, elliptic curve and RSA for these quantum safe codes. Basically math problems based on lattice geometry are some of them that a quantum computer just is like a normal computer, then it can't break.
Yeah, and so you're totally right. As I hang out with lots of CTOs of other companies, especially the banks, there's a lot of focus on moving to new algorithms. So in theory, from the encryption perspective, if we move our algorithms, we should be fine, in theory?
Yeah. I think, first off, I wish a quantum computer would speed up bank lines and call centers. That would be fun. I don't care about
That's what the LLMs are doing.
That's true. I don't care about my money. I just want a better service.
Yes, exactly.
But sorry, what was the?
Yeah, no. So we're going to another question.
Yeah.
Over here.
Really enjoyed the talk. You said in 2026 unlock is
Wait,
reinventing.
are you quoting me?
Oh yeah.
I'm scared now. I didn't mean it.
Yeah,
I didn't know what I was saying.
We can have a general conversation. So
Okay, cool.
it was mentioned that reinventing how we do AI with tools Quantum provides, and NVIDIA also launched the newest tech to use LLM with Quantum. So I want to understand, where do you see people from AI side actually plugging into photonic quantum today? Is it through PennyLane or some other tool you are thinking about? Like how we can think about application as entrepreneurs? Because right now when we think about quantum, it is still more on the research side, and big companies will have access like a deep research labs, or can an entrepreneur with maybe $1 to $2 million funding can think about applications?
So because you mentioned PennyLane, that's our software stack. You have a free PennyLane T-shirt under your seat. I'm just joking.
And you get a quantum computer.
Exactly. So PennyLane is our software offering. Like any computing architecture, you've got the hardware and you need to interact with it. You need software to log in and run the programs, program them, and so forth. We've seen, there's two answers to this. One is, how can quantum become like a quantum version of AI, like quantum machine learning or quantum AI? There's things happening there, but it's still a big question mark. Like, how do you kind of supercharge what we're seeing with LLMs to have a quantum version? It's TBD. I think there's something there. The naive way of thinking about why it would be is quantum physics is based on linear algebra, and so is a lot of the AI stuff, and there hopefully is some algorithms that could kind of overlap.
So you mean like instead of taking 6 months to do an LLM new training run, you could run a quantum training run?
Yes, that's right. Well, exactly right. And we do know, it's probably in the 2030s, unless there's breakthroughs, that there is a quantum algorithm that can actually do linear algebra, like systems of linear equations, solve them, and a lot of other fundamental things that traditional AI uses in exponentially faster. And so, but it takes a larger quantum computer. That's the challenge. But the other thing, we have an internal kind of agentic AI tool called Jukebox. And it's really cool. Our team has trained it and done everything and made it available on Slack for our researchers and everyone in the company. You can actually ask it to, this is not other programs, many other people do this too, but you can ask her to summarize a research paper, but then pop out why Xanadu people care about the results as well. So you can kind of like tailor it to Xanadu's stuff. There's also really amazing things where, again, others do it too, but we've really tailored it to our needs. You can go to a textbook and say solve equation, blah, blah, blah on page, and it just sort of outputs it in LaTeX too, which is really fascinating. I would say, there's a lot of hype and awesomeness around AI. I think with what we're doing, we're seeing that kind of come out with chip design. So we do all our chip designs ourselves here in Toronto and send them off to different foundries. They make or fabricate the wafers based on our design, send them back, and we take over from there. But the layout of these chips and the optimization, we have spent time that has saved months ultimately in doing that optimization stage. We can even send a chip, a picture of a chip layout and say to Jukebox, what's wrong with this, or like analyze it for us. So it's been really amazing for the optimization side of things, along with the stuff that you're seeing every company use it, say for HR and accounting and other things like that.
That's cool. But so that currently doesn't use quantum, but it is your way to get towards quantum.
That's right.
And then, is there like, how do you use the your 7-foot refrigerator racks? Like, is it literally like an API?
It's an API, yeah.
Okay, from
That's
the cloud.
right.
So you are using internally. People are just running experiments on it, or
That's right.
Okay.
Yeah, we don't have anything publicly available at the moment. It takes time and people power to actually keep these things running.
Oh, really? Like,
to the
so
specs.
give me an example. Like, it's different than running a regular rack.
Yeah, it is
Okay.
because one example was this 7 million years down to 2 minutes.
Yep.
That was a demonstration of what is known as quantum supremacy. We had that available in our Xanadu cloud for a year and also AWS for a year. But because it needs to be so precise, you need to kind of initialize it every week, and that can take a day or two to do it.
Okay.
A human has to do it. So.
And they're like physically, like they've got scopes and they're looking and seeing, oh, this wire is no longer
That's right.
at the tolerance, and like
Exactly.
this. Okay, so
you can benchmark it through the classical data, get the data, and look at it and say, okay, there's an issue here. It's probably this physical reason of why it's acting that way.
Another question.
Hey, Christian, really thank you for being patient with us, educating us about quantum computer. So I have 2 related questions about the implications of large quantum computers. So one is, how many years do you think we still need to, to see the first quantum computer which can crack, RSA 512 or 1000, like a 10024 or ACD-SA? And my second question is, why aren't we seeing people taking actions? Because people can literally now record everything on your Wi-Fi network, on your, the internet traffic. They can store it and wait until that day comes, and they can get all your social insurance numbers, basically everything, right? So that's my 2 questions.
Actually, the second part is what I was going to mention. Thanks for reminding me. Is that getting back to like how quickly should people act? For most information, sooner the better. But there is some information, as you mentioned, like medical records, patents, things that have decades, potentially longevity. All governments now are downloading stuff. And even if, getting back to your first part, it's probably the end of the decade, early next decade, to hack, say, 512, and then beyond that later on, barring any big theoretical improvements. But let's say that happens, say, in the next 10 years or less. Some hacking of that. The data still needs to be secure for more than 10 years. As I mentioned, medical records, patents, secret source of companies, because I can probably download everything here now, but it's encrypted. It just sits at home and I can't crack it. So I hold on to it. I won't personally, I've got better things to do, I think, but I would hold on to it.
It's getting weird, Christian.
It's getting very weird. And I would you hold on to it, and then 10 years later, it's I know some of that's valuable. So it's a really good point. Certain, defense is another great one. But I would say that if you look at banks, I'm picking on banks for some reason today, but banks, in the early days, we were looking to do stuff with banks and about quantum security side of things. There was, I forget what it's called, SHA-1, SHA-2, like a hashing sort of function. It was known that SHA-1 is weak and could be hacked. The banks were still using it. Like, they just didn't care. And there's a kind of a non-coolness or a non-technical reason why. It's because they're insured. Like, you can't, it's really hard to sort of say you've got to spend more money on something when you've got insurance or there hasn't been any widespread hack. Like, if someone hacks Bitcoin tomorrow or the banks, they'll get into action very quickly. But it takes a huge penalty or a huge cost to get people to act. And it's like life insurance. I mean, I don't have life insurance. I value my life quite low. But, you know, it's...
I mean, you have a kid now, so you probably need life
yeah, he's not going to get life insurance either.
Not him, you in case...
For him?
Yes. Yeah. You have dependents.
I just still don't know what that means. He's so young. But yeah, it's a really fascinating thing where even if you know the solution exists and they should be doing something, for other non-technical reasons, even when you know there's a threat, I think things are slowly changing now, but even Biden, I think when he was in, he signed some act or executive order for post-quantum to be implemented. And when we went to Capitol Hill and people spoke to congressmen and so forth, they were like, yeah, that was the first step that was needed, but now the implementation is going to take forever. Like, it's wild. I mean, you know, it is what it is, but that's another thing that as entrepreneurs we need to take into account. It's like we see the solution, we see the answer, but for some silly reason, the uptake is going to be slow.
Yeah, like I said, it was when I talked to a lot of the bank CTOs, it is on their radar. How fast are they moving towards replacing? I don't know, but let's keep going out. Question over here.
Hey, thank you. I've followed your career for a number of years. I remember when you were in CDL.
Yeah.
He's going to CDL tomorrow.
Right?
Yes.
Awesome. And I thought maybe this is apt since it's Toronto Tech Week. And I've been basically speaking to young founders who've been talking to me and asking, like, where can I get help? Where do I turn? And I think the big question that I'd like to ask you is, and please take it the right way, since you're an Aussie, you'll get this sense of humor, is what's keeping you here? In other words, what are the best things about what's going on in Toronto specifically that allows for your company and your team to really keep pushing this boundary? We can talk about how many years, you know, we'll reach certain technology, but I think it ultimately, and I think it's, again, apt that we're here at Shopify, I really believe culture is really important. Like, it's the central piece to what goes on. So could you please maybe brag a little bit about what's going on here in Toronto that basically makes Xanadu and, let's say, the team and the technology just keep pushing and beating other competitors out there?
It's because your barber's here.
Exactly.
Mine too.
I always get this question. I thought there was like some tipping point where I'd get it one too many times and I'm going to leave Canada. I think this is it now. I'm leaving tomorrow. I honestly think I don't even think about it that way. I think what we do really comes out in that way, but that's not the motivator. I'm not trying to do any, I don't know how to phrase it. I just like being here. I like being here in Toronto. So I came from Australia originally, and then as soon as I arrived in Toronto, I just felt like home and wanted to stay. So it's nothing more or less than that.
You said like 85% of your employees are here or something?
Yeah, that's right.
City?
In the city, that's right, yeah. So that's the main thing. That's the fundamental sort of level. But then on top of that, there are sort of extra stuff that resonates where I'm just sick of people saying you can't do something here. You know, it feels like it's slowly changing. So it's kind of like going against the grain and trying to say, well, you know, you can go, but I'm going to stay. It's like, you know, we'll show them kind of thinking as well. And I think it creates an edge. It creates a uniqueness as well. I also think that the more people stay, VCs and also other entrepreneurs like to point to something in the past that, well, you know, Shopify has done it, so why can't we do it? And things like that. Some more success stories makes it easier. There's been much more funding. But for me, it wasn't a case of, the fundamental thing was I just like it here. It's that simple. There have been times a lot where we think of, it would be fun to move, to be perfectly honest. Even we do a listed like Shopify on TSX and NASDAQ. TSX, they're really great, but it's not because of them, but the processes just made it like, oh, I wish we were in the US and just were on the NASDAQ. They made it so much easier for us. And there's times like that where you have kind of a moment of weakness. where it's like, I wish we were in the US. It seems like it'd be better. But I don't know if it would be better, actually, and we're not going to try it out. It also reminds me, when you watch movies or hear, like, I'm an immigrant and other immigrants kind of come to the US particularly, and they're like, they think it's going to be much easier or better in the US. Maybe it is sometimes, but it's not like you kind of arrive in the US and then everything is handed to you, So obviously it depends on where you come from. I'm coming from Australia, so it's not too different. But no matter where you go, you're going to have to work hard. And I don't think it's, I don't know if it's easier in the US. I'm sure I just picture we go to Texas or San Fran and the usual shit just comes up, but you can do great things here in Canada.
Is there something about the Canadian ecosystem that makes the employees like more well suited to Xanadu? Like U of T has a program, or like is there a program around that you're like, oh yeah, this is a better fit, or you're just like, hey, there's great people everywhere, and actually there's lots in Toronto?
Yeah, I think it's just quantum is a little unique, and so getting the right people. I think anywhere in the world, people like to go to the Valley because they think, and on average it's probably true, at least the more volume of this happening, where the best people are. So if you manage to get the best people early like we have in quantum, then it's going to attract other better people. They don't really care where you're located. Like in 50 years, maybe this is, or sooner, but this could be the epicenter of everything in the world, Toronto. And so I don't think people care about whether it's Toronto or not. I'm sure they do in some aspect, but where the most ambitious people want to work with the best and test themselves and work on things that they think are going to change the world. So wherever that is, it doesn't really matter. Just for historical reasons, I guess it's in Silicon Valley mostly, but even that's changing, throughout the US and Toronto.
Yeah, very cool. All right, more questions? Oh, we do. Hold on, she's got the mic.
Hey, first of all, thanks. That was like a fascinating talk. Thank you for educating us on quantum computing. I was particularly curious about the portion that you mentioned around the interface between quantum computers and traditional computing hardware. I was wondering if you could help us understand that a bit more deeply. I know you mentioned something about logic gates, but...
Yeah, it's very simple to say. It's the devil's in the details, but whatever you have in classical computing, you have some analogy in quantum computing. It's kind of that simple. The difference, though, is in why you see speed-ups in certain situations is you can leverage entanglement, superposition, and interference. But one of the key ones is really entanglement. That's probably at the heart of the answer to your question. So entanglement allows you to do some weird shit. Like it's actually made, it's like a resource, it's like gas. And you need that. If you don't have that, you can't see any speed-ups. But it allows you, outside of computing, allows you to do teleportation, allows you to do computing, as mentioned, sensing, and many of the characteristics of the quantum speedups originate from entanglement. It's the famous thing that Einstein pushed against heavily, where he came out with a paper. It's known as the EPR paradox. It's not really a paradox, and it's named after Einstein, Podolsky, Rosen, the authors, which said, we'll show you how screwed up quantum physics is. This is not 1935. When things were probably already settled by then, not really, but they thought it had, and they said, we're going to show you how stupid this thing is. You're telling me that if you assume all these things, you can have this, I think they said something like, you've got these two systems, they interact in a certain way, and one goes to one end of the solar system, and the other one goes to the other end of the solar system. But they're still connected or entangled or correlated in some way. Roughly speaking, if you do something to that thing over there, it'll immediately simultaneously have an effect over this thing here, there. You don't know what the effect is until you send classical information. That's why you can't go faster than the speed of light. But they were kind of showing the people in quantum physics at the time, look, see how stupid this is? And it turned out to be this was entanglement. And it actually is something like, remember, all these folks came from, like we all do, where they came from classical physics, where you didn't see these things. You don't see these things at our level. So it's very fascinating. Like, I don't know how they came up with quantum physics. Like, a lot of it was guesswork, which is wild, experimental, sort of validated things, or gave them ideas on where to search. But entanglement really is the key feature that's different between classical compute and quantum compute.
AKA spooky action at a distance.
Exactly.
It's a bit more fun name.
Hi. So Christian, earlier you mentioned this idea of a quantum data center, and I was sort of wondering, like, traditional data centers take up so much energy and cooling, and I imagine it would like scale accordingly with like the requirements for quantum cooling. So I remember reading something about how Meta and Google were looking towards nuclear power in order to power these like data centers. And I'm just sort of like wondering, like, could like quantum data centers exist at scale where like the way traditional data centers would? And like if it does, how would you like power something like that?
The good thing is that once you have a large enough quantum computer, it would be equivalent to hundreds or thousands of normal data centers. So you've already got that extreme scalability baked into a quantum data center. So given that, along with the fact that our data centers will be roughly, the key part of it, 3 to 5 tennis courts, it should be whatever the equivalent is for a classical computer of that size.
But those are for just quantum operations, right?
Say again, sir?
That's going to be just for quantum operations.
That's
You're going to
right.
need the classical side.
We do need classical compute as well, which people don't really know or talk about that much. It won't be as much as, so we still need cooling like a traditional data center. But I guess the theme is it's not going to, if you extrapolate the number of parameters you need to train now in data centers, it's like at the moment trillions. And if you want to keep seeing the latest version of an agent, it's just going off the charts. And in some cases, extrapolates to we don't have enough energy for that. At least currently. A quantum computer doesn't sort of go exponentially up like that. It still maintains kind of like a logarithmic sort of suppression to the scaling. So at this point in time, there's nothing to sort of worry about for energy. There's no energy constraints, and it's looking good. And the extra cooling in our case is far less than anyone else's, and it doesn't put you into a regime of exponential sort of blow up there.
I'm going to go to another question, but before we do, I have a question for you on sci-fi, because in the AI world, there's lots of like movies that people are like, oh, that's like, we're going to like Her, or there's like all these movies. Like, what's the sci-fi movie that is close enough for people to be like, oh, I need to go watch this to understand quantum? Like, what's the crazy, far-out sci-fi movie for quantum?
I don't know. I don't know if there is one, actually.
Really?
Quantum is, it's funny though, quantum is appearing in more and more TV shows.
Okay.
I forget
Well,
the one.
Quantum Leap?
Quantum Leap.
Remember that show?
Even in, I think I watched the first episode. It's a Disney show. I forget. It's about the president. And at the end of if you haven't seen the first episode, I'm sorry, but at the end of the first episode, it zooms out, and you think you're in a modern day world, and you are, but it has, it's actually a big simulation.
Oh, okay.
One thing I can say is I don't think I'm correct, meaning there's a high error bar here. I don't think you can get AGI with, and however you define that is also a bit tricky.
Without quantum?
Without quantum, yeah. The reason is that ultimately what are you trying to do is simulate our reality, nature. Nature has a digital part to it, or it can be simulated using a digital part. But you're leaving a lot off the table with the analog side of things. And so I'm always curious about that, like what happens to that bit you're cutting off? And so I think you need something like, not necessarily, but something like quantum computing, which inherently is quantum physics, which does have a discrete and continuous nature or analog nature to it. So anyways, I'm not sure.
I was thinking sneakers might be quantum.
It wasn't called a quantum computer, but yeah.
I think that thing is a quantum computer. Anyway, next question.
That's cool, yeah.
Yes, thanks much for the very insightful fireside chat. My question, or before jumping to the question, transistors were invented almost 70 years ago. And now every one of us has in their pocket billions of transistors, and we have the capacity that's even more than the entire world 60 years ago, for example. When do you think, if it's possible to start with, that this all quantum computing will be commoditized, that not data centers or large companies, that each one of us has this, and what time horizon, and what world would be looking like at that time?
No one knows the answer to that. I'll try and make a guess, but it could be heavily wrong. I would say in the 2030s. The challenge, though, is how do you reduce the extra stuff like the cryogenics or laser cooling, things of that nature. I firmly believe it's possible. Some people say it's not possible to ever get there. I just, like you said, like the amount of shrinking of the transistors and to what we started off with from 70 years ago, it's mind-boggling. And so if things head in that direction too, like a quantum Moore's law or something equivalent, I see no reason why we can't. It's definitely not, going against the laws of physics. That's always the starting point. You're not violating anything. So
The laws of quantum physics, though.
exactly, yeah. So that, it says it's possible. So I think at least in the mid 2030s.
Cool, and maybe last one.
What would it still take for frontier, like machine learning labs, to switch from traditional computers to now quantum computers?
It would take, they would have to understand what quantum algorithms are being used and in what way they can leverage it. Because quantum doesn't solve all the world's problems. It doesn't make, Instagram load faster or emails faster, but it's a subset of problems, but the weighting of those problems, meaning how important they are, is huge. So drug discovery, material design, AI, finance, logistics. So it really depends on what your problem is, and that's what we're doing with large partners and forming partnerships all the time is, where are your biggest computational challenges? Going in, our team, and investigating where, and a lot of time it does occur, and then finding what algorithms. So it's a complex problem or question. There is a solution, but that's typically how you go find the solution.
All right, I want to thank Christian for coming and joining us today.
Thanks, Vlad. Thank you.
One more time, that was terrific. Wow. I don't know what you thought about that. I don't really care. I really enjoyed it. So the questions were great, though, so I can tell that many people were engaged. What did we talk about today? Because going back, this is about 4 hours of content. We started with building the platform, the Universal Commerce Protocol, or UCP, and how we bring commerce into the agentic era. We talked about SimGym, which really ended up, I think the big takeaway for me was the conversation about training agents to act like humans, what that means, and where you don't need to mimic humans exactly in order for that to be accurate. We then talked about River, what's led to River, how we're doing development in Shopify and how things are changing. And then you just heard this amazing fireside chat about quantum computing, which is a completely different topic from what we've talked about, something that I knew very little about. It's not something that I'm working on regularly at Shopify, but really fascinating in terms of where things can be headed into the future. So going back to the beginning, really putting this program together today was about expanding kind of perspective and what's possible, what we're building today, what we can build in the future. I tried to bring out a number of perspectives that Shopify has on development or how we approach products and platforms when we're building for all of you as well. And then again, just expand further with a different type of topic to think through where things are going and what might be changing in the future. Because everything I think that we hold as our assumptions are open to being changed, some of them much sooner than we maybe expect that they would be. All right, what's next? Next, we've got a reception. So the idea is to keep the conversation going. Many of our speakers should be there. Our talent team will be there as well. This is a reception sponsored with, co-sponsored with Shopify Ventures, our investment arm as well. And so there will be people there you can talk to if you're interested in what we do and how Shopify invests in the future of companies that aren't Shopify as well. And then many of us from Shopify will be around as well. My encouragement to all of you, if you haven't met someone new today, whether or not that's a person at Shopify, irrelevant, try and meet someone new, join us at the reception, have some bites, have a drink, hang around and have a conversation. This is, again, in the spirit of Toronto Tech Week. We build relationships, we build culture, we build community, and then we build together. So please join me upstairs, and one more round of applause for all of the speakers and everything that they put together for you today. Thanks for being here.